During the 13th century, the Western world had a lot of questions about angels. Medieval society was deeply religious, with Christianity permeating the entirety of culture, from politics and law to entertainment and science. The bulk of the Dark Ages had passed, and people now had the security they needed to ask questions about the world around them, a world which was both divinely conceived and maintained. With the Bible as a foundational text for understanding everything, from the nature of man to the natural world, scholars like St. Thomas Aquinas and St. Bonaventure asked, what about angels? These mysterious and very real entities were found all across the holy text, and they ranged from familiar to incomprehensible. Did they have physical bodies? Were they limited by time? Did they possess the will and emotions of men? These were real questions about the nature of divine beings, asked in earnest using Aristotelian principles. Now, to be clear, there weren't really any scientists at this time. There were churchmen who moonlighted as scientists. Science worked in service to religion as a means by which to understand God through his creation. And so the learned men asked, how many angels can dance on the surface of a pin? My gentle and of course very modern apes, today I'd like to tell you a story. It's a story that's been told before, but I don't think it's been told in this particular way, and certainly, at least with this medium, not with this particular focus. So when I was getting my bachelor's degree, my least favorite part of every science class was that introductory bit, the first lecture or so, where you have to learn about the history of whatever science it is that you're talking about. You probably remember this yourself from high school biology or like early university biology or related science classes, where you have to learn about which crusty old person discovered which thing or process. Why yes, you do need to know the difference between what Hooke did versus what Van Leeuwenhoek did. It is going to be on the exam. I'll give you a hint, they're both into microscopy. To me, the history of how we learned the science that seems so obvious today was just so boring. Teach me about what makes a monotreme, or what the Golgi apparatus does. It's like the post office of the cell. But one of the cool things about getting older is that the things that used to bore you sometimes become just a little bit more interesting. Ask any millennial about birdwatching, they're all over it. And once you get the opportunity to learn just a little bit more about a subject that maybe you previously had no interest in, sometimes the floodgates will open, and you'll realize how fascinating and shocking and relevant that subject has always been. So my name is Erica, this is my channel, gutsickgibbon, and what I normally do here is I keep you up to date on the latest discoveries surrounding my area of expertise, which is human evolution, and I debunk a whole lot of pseudoscience, and usually I'm picking on some variety of creationism. Creationism here in the West comes in a few flavors. Young Earth creationists believe the Abrahamic God created the Earth and everything on it more or less in its present state roughly 6,000 years ago, and that the fossil record and the rest of the geologic column is the result of the global flood from the Noah's Ark story, which occurred some 4,400 years ago. Now obviously that means that they have a real bone to pick with all of science, but particularly geology and evolutionary biology. Old Earth creationists accept conventional geology but spurn evolutionary theory, usually opting for a sort of progressive creation. Finally, intelligent design advocates can be old or young Earthers but deny that evolution can create all of modern biodiversity as an independently operating process. God must tinker along the way. Finally, there are religious folks who accept all of conventional science, believing that God uses evolution as he would any other process, the theistic evolutionists. The theistic evolutionists are only creationists in the sense that they believe God is responsible for the process of evolution. They accept that humans are apes which descend from other apes in the ancient age of the Earth, and as I said, all of conventional science, and for that reason, we love them very much, and they are welcome here.
Talented, brilliant, incredible, amazing, show-stopping.
Now, other creationists have been trying for decades to get creationism taught alongside conventional science in schools. Many of them feel as though society has it out for them, not just creationism, but their faith in general. They feel that the theistic evolutionists are compromising their faith to fit in, forcing the Word of God to acquiesce to modern science by twisting the text itself, taking Genesis allegorically, for example.
For those who claim to believe in the truth of the Bible, they should understand that in accepting the secular time frame and denying the truth of a global flood, there are far-reaching spiritual consequences to consider.
And historically, many of them also feel that modern science, specifically the idea that Earth is 4.5 billion years old and that humans and all other living organisms result from the slow process of evolution across hundreds of millions of years, was specifically drummed up to oppose them and to pull people away from the faith.
Where did the idea of millions of years in our present world, where did it really come from? Well, we have to go back to the late 18th century, early 19th century, when there were atheists, deists, who rejected God's word, but they were trying to come up with how long it took for the fossil layers to be laid down. Where'd the fossil layers come from? So they wanted to explain it all within naturalism. Well, naturalism is atheism. Naturalism means everything happens by natural processes, everything is material. So how do you explain the fossil record without the supernatural? You reject God, you reject his word, you reject the flood of Noah's day.
First of all, methodological naturalism in science is not atheistic, but we'll get to that in a moment. Suffice it to say, many modern creationists think that conventional science like evolutionary theory is, and always has been, focused on drawing people away from religion and from Christianity. This idea is as true as creationism is, which is to say, it is demonstrably false. I'd like to tell you the story, the epic, of how science and religion killed creationism. Seemingly unlikely bedfellows in our current culture, no? But for the vast majority of Western history, science went part and parcel with religion. They complemented one another in the eyes of naturalists and the public alike. Now, to be fair, the birth of many pseudosciences, from flat earth to creationism, came from an inappropriate relationship between science and religion. However, the deconstruction of those same ideas often came from the same marriage, albeit a more egalitarian one. For the most part, it was religious naturalists that killed creationism, at least this go around. This video is about the early history of scientific discovery and how the conflict between religion and science eventually found harmony and took creationism out in the process. As a doctoral candidate myself, I'm fascinated by how science is received by the public and the sordid story of its interaction with creationism through the centuries. Our research question here is pretty obvious. How and why did the original flavors of creationism emerge? And how were these concepts toppled by science, particularly at the hands of religious scientists? When this tale is through, you'll understand how we discovered the Earth is very ancient, how we discovered that evolution is responsible for all modern biodiversity, including our own species, and how modern creationism is, in many ways, the same creationism of centuries ago. You'll probably also understand how it differs, although I won't point that out just yet. This is a true story, although it's one that I think creationists through the decades and the centuries have done a great job hiding from you, which is why I'm gonna tell it. A lot of people have made a lot of money trying to convince the general public that science and religion are necessarily enemies. The sources for this video, and for the succeeding videos, are numerous. I now have a new shelf dedicated just to this topic. So if this is something that interests you, please check out the sources for this series. They're in the description, and they'll also pop up whenever and wherever I mention them. Now, like I said, creationism comes in many flavors, but they all share one thing in common. Their root cause for denying science to varying degrees can be found in their interpretation of the Bible. Specifically, it can be found in their plain reading of the first book, Genesis. Using this text, which they believe is divinely inspired and thus inerrant, they argue against scientific consensus on the age of the Earth and evolution, along with many other topics. But has that always been the case? Or is the definition of what is plain or literal when it comes to reading the Bible just as subject to change as the culture, critters, or crust of the Earth? How has Western science and religion changed over time, and where have they clashed with other aspects of human culture, like politics. This is a long story, and I'm also long-winded, so as a marker for our series here, this video primarily concerns itself with the first wave of creationism, which I am calling the diluvialist wave. The climax of this entire story is notoriously placed in the 20th and 21st centuries with the Scopes and Dover trials, as well as the birth of modern fundamentalism, but I'm going to argue that by the dawn of the 1900s, creationism was dead, and science had killed it with the help of religion. How did that happen? And what does that make the creationism of today, or even that of the early 20th century? All of that is soon to come, but our story begins much deeper in the annals of history. Our roadmap for this video is important. We need to know the history of human thought with regard to the age of the Earth and evolution, but that story actually requires us going back pretty far, before any major discovery in either subject, before the invention of creationism, before the advent of Christianity, before the origin of civilization itself. And this is because, as with all stories, the history that precedes the climax is what shaped it in the first place. In this case, it might have even made it inevitable. One side effect of being an intelligent animal seems to be an understanding of death. First, we're born, that is to say, we start being here. We're here for a while, interacting with each other and with the world at large, and then we die. That is to say, we stop being here. Other organisms do the same thing, sometimes for shorter periods of time and sometimes for longer periods of time. The impermanence of stuff, though, from animals to cities, is obvious to every human on the planet. Things start and then they stop, and they overlap in weird ways. Early human societies understood beginnings and ends, the concepts of impermanence and change. Other hominins did too, so it was only a matter of time until the first human looked down at the ground or up at the sky and thought, how long has that been here? And from the very first people capable of leaving records behind, there were those who answered that question with a very long time. For some, the answer was that the Earth had always been. Much of our understanding as to how ancient people conceived of the world and of its age comes from their creation stories, from their cosmologies, from their king's lists. By looking at stories and relics left behind through space and through time, we can understand that ancient people thought the Earth came about from a myriad of different ways, depending on who you talk to and when you ask them the question. Sometimes the Earth is born from a previous world thanks to a mother deity. Sometimes it is brought forth from chaos by a god or goddess's words, music, or secretions. It can be assembled by an earth diver or sent by a god to grow from another god's dismembered body. Sometimes a giant egg hatches. One Egyptian creation myth has the world emerging from the distant past out of a Dead Sea that stretches infinitely in all directions at a moment called Zep Tepi, or the first occasion. For me personally, I do like that better than the world having emerged from someone's spit or seminal fluid. The timing of things in many of these stories is pretty ambiguous. There is a before time, that is to say, before the Earth was formed, and then the Earth is formed, and history begins. Context in many of these stories suggests that the before time was not brief. Countless world iterations sprawl into the past, or chaos reigns, or the gods confer, or the egg incubates. And this holds for the Hebrew creation story too, actually. For instance, how long does the Spirit of God hover over the primordial waters? How long were the primordial waters there? The point, of course, wasn't to put a number to things, it was to contextualize humans' existence. Humans didn't exist, and then they did. It's interesting how unimportant putting an actual number was to things for these ancient people, but they had bigger issues at hand. They needed to secure consistent water and food and safety before they could even begin to start putting the big questions to papyrus. Some civilizations did take a stab at placing a numeric age to the Earth. These estimates can be gleaned from some civilizations' king's lists. For example, the Sumerian kings list includes antediluvian reigns stretching well over 200,000 years into the past. There is no reason to suggest that Sumer itself existed for 200,000 years. However, the Sumerian conception of their own history may have been very ancient. Some scholars have suggested mathematical conventions or narrative reasons for such a deep history as well, but this is one of the first examples of a long numeric time frame given to at least human history by a people group. Still, this king's list is permeated by the influence of the gods. It isn't an attempt at geology, but a light theogony with human cameos. The Greeks, who hadn't invented glasses, but whose texts and histories would go on to influence many early Christian thinkers, would produce some of the first written records musing about the age of the earth, and from a naturalistic perspective. They were one of the first civilizations where writing and free time converged and allowed people to sit around and consider, ponder, and mull over everything from philosophy to the natural world. One of the first of these was Xenophanes, a Greek poet from the 5th and 6th century BC. Xenophanes, perhaps controversially, believed that the gods were relatively uninvolved in the affairs of humans, leading him to propose a naturalistic explanation for natural phenomena, from St. Elmo's fire to fossils. He proposed that fossils of marine animals on land meant that land was once covered by water. Marine transgressions explained shells, fish bones, and seal prints being found in quarries and mountains. The sea and land being able to switch places. This, as you can imagine, was a pretty groundbreaking idea. Still, it was well reasoned and accepted to the degree that Herodotus, considered the father of history by many, would propose in the 5th century BC that the Nile River had once been a gulf, and that perhaps the change from gulf to the river that people now saw today had taken as long as 20,000 years. Xanthus of Sardis would propose that the marine fossils found on the plains were formed in roughly the same way. Then Aristotle would take things to the next level in his piece Meteorologica, which is arguably the first dedicated text on geology in history. In it, he mused on the nature of volcanoes, earthquakes, and marine transgressions alike. Aristotle was different though, because he put a timeline to things. Rivers and seas could form and dissipate in perpetuity because the Earth was eternal. That's plenty of time for the Earth and geology generally to mix things up, right? Forever. Now, critically, Aristotle reached this conclusion from a naturalistic perspective. He looked around him and saw every kind of geologic formation in various states of growth or collapse, from oceans and mountains to floodplains and foothills. And this was a pretty popular way of thinking, in part because it was Aristotle who was the one proposing it, but also because there was just no way to put a finite number to anything. People tried, of course, but it was always kind of a ballpark thing. And this was due in part to the fact that no one was writing this type of thing down. Thinking was still in its early stages with regard to being put to paper. So the eternal nature of the earth and the universe took hold with the Greeks and would hold through the Romans and the early Christian thinkers and through the death of Jesus. Now we got to keep an eye on those Christians because they're about to take the baton from the Greeks and Romans and start to shape Western thinking themselves. Many of these early Christians, such as Theophilus and Sextus Julius Africanus, didn't put much stock in the idea that the universe or the earth was eternal for obvious reasons. Their holy text put a distinct start date on the whole existence affair. The earliest Christian thinkers had bigger doctrinal fish to fry anyway than quibble about the age of the earth, which is why very little is written about it at all prior to Augustine. What is written, such as the musings of Basil in the 3rd century AD, is dismissive. Some things, Basil would argue, cannot even be known, so why bother? Early fathers of the church, though, did have some pretty flexible ideas when it came to time, especially with relation to God. This was primarily due to verses Psalm 91 and 2 Peter 3:8, which each use a 1,000-year chunk of time to convey that God supersedes human temporal conception. One might think that this would be used to argue that the 6-day creation week in Genesis is actually 6,000 years. Like, that time period would have taken 6,000 years if a day is like 1,000 years to the Lord. But no, instead they used that concept, that 1,000 years to a day with God versus humans type of thing, to argue that all of human history would take approximately 5,500 years to 7,000 years. But that's human history. That is set apart from the actual age of the earth in the minds of some of these first thinkers. Like the many creation stories, cosmologies, and kings lists before them, they didn't really have much to say about the period prior to creation, and why would anybody care? There were no people back there. Human history as a rather short affair would be found in the writings of many thinkers in the first few centuries after the death of Jesus. It's found in the Epistle of Barnabas, as well as in the writings of Irenaeus, Hippolytus, Methodius, Lactantius, Julius Firmicus Maternus, Tychonius, John of Damascus, Clement of Alexandria, Eusebius, and many other cool guys. Now, from a scholarly perspective, there's disagreement when it comes to the question of how old did each of these guys think the Earth actually was. But truthfully, after looking at a lot of old writings, I think that it was simply pretty unimportant to them, especially compared to, determining when Jesus Christ was going to come back. I cannot stress enough how much time and ink was spent and spilled arguing about and trying to determine generally when the second coming was going to occur. Every single one of these early church fathers had a perspective as to when Jesus was coming back, although I will say a lot of them thought the answer was ambiguously soon, so it's not surprising that they weren't really super concerned with the geological age of the Earth. Now, that is not to say that they were not interested in the book of Genesis. And this makes sense. If you want to understand the end, then you probably want to have a firm grasp on the beginning, which is actually a little bit harder than it sounds. When it came to the creation of the earth, virtually all of these thinkers agreed that the 6 days of creation in the book of Genesis were literal days. However, they struggled with the idea that they were just days. Origen, in his homilies on Genesis, puts a profound allegorical power onto the text, and Augustine would as well in his work The Literal Meaning of Genesis. Both men seem to have interpreted Genesis as being pointedly narrative in nature, structured intentionally by God himself to be comprehensible and understandable by humans. So, fascinatingly, as I understand it, Augustine thought that the 6 days of creation in Genesis weren't 6 literal days that God took to create the earth. Instead, he thought that those 6 days were God's way of explaining creation in a comprehensible way to humans, and that instead, God actually, historically, like what God literally did was like snap his fingers and do all of creation in a mere instant. So in this way, Augustine does consider the 6-day creation allegorical, but not because he thinks the actual time that creation took was like billions of years, but rather it actually took no time at all. And his reasoning is pretty simple and intuitive. Why would the God of the universe arbitrarily take 6 days to create the universe when he could just snap his fingers and do it in an instant? The answer is that he didn't take 6 days. That's just how he explains it to our dumb human brains. Augustine supports this notion by pointing out that the 7th day of creation can be interpreted as still in progress, not a literal day. In Literal Commentary on Genesis, Augustine argued that Genesis 1 through 3 had been written obscurely for the purpose of stimulating our thought. No Christian, he said, would dare say that the narrative of Genesis must not be taken in a figurative sense. Ironically, Augustine would be hugely influential to creationists thousands of years later for quotes on the authority of Scripture. But Augustine was also clear that authority was not synonymous with unchanging or clear-cut. He would specifically warn that there was a great danger in just blatantly, bluntly, obtusely taking Scripture literally. On Genesis, Augustine urged readers to choose the interpretation they could grasp, because different interpretations are sometimes possible without prejudice to the faith we have received. In such a case, we should not rush in headlong and so firmly take our stand on one side that, if further progress in the search of truth justly undermines this position, we too fall with it. Case in point, Augustine accepted that the earth was in fact a globe, despite some biblical interpretations proposing otherwise, and despite some major Christian thinkers arguing that the earth was in fact flat due to scripture. Interestingly, though, Augustine thought that the other side of the globe was only open ocean, for how could the inhabitants of these hypothetical continents have heard the good news about Jesus Christ, as scripture outlined? Critically, this means that for many of our most influential and earliest church fathers, their exegetical understanding of Genesis is that the six-day creation was allegorical. They did think that human history could be contained within a 5,000 to 7,000 year time frame, but that wasn't due to any specific scriptures. Rather, this had more to do with trying to anticipate when Jesus would return on the basis of some scriptural interpretations. And that's human history anyways, not the age of the earth. This is a foundational point to our story that you need to remember from here on out, forever and ever until the heat death of the universe. Prolific church fathers reached the conclusion that the six-day creation in Genesis was allegorical and not a literal history with absolutely zero influence from science. As Christianity gained power in politics and in culture, Christian thinkers continued not to put a specific age to the earth. Scholars prior to the Reformation, such as Hugh of St. Victor and Thomas Aquinas, would continue to hold this idea that scripture simply did not speak to the age of the earth, or that there may have even been a vast period of time prior to the creation week. Eventually, that idea is going to become known as gap theory, and just wait, it's gonna be big. Aquinas in particular argued that nature is purposeful and governed by reason as set forward by God. Natural science will never contradict scripture. As for Genesis, the manner and the order according to which creation took place concerns the faith only incidentally. People did argue as to whether or not the six-day creation week was allegorical or literal, but most people did agree that human history could probably fit within 5,000 to 7,000 years, and that the time prior to the creation week, however long that actually was kind of just inconsequential. This was the case for the whole of the Dark Ages in the West. The age of the Earth just wasn't something anyone thought much about, and the same would be true for most of the coming Renaissance. Some Protestants, like Martin Luther, Philip Melanchthon, John Gertrude, Sethus Calvisius, Johannes Kepler, yes, that one, and John Calvin spent this time arguing about when creation took place, both the year and the season. Side note, I think thematically, spring makes the most sense, right? Like the creation of new life and new things coming back after the dormancy of winter, or chaos.
No.
Anyways, in the Western world, this is generally where things stayed until the 1600s. Arguments about when creation occurred, the timeline of human history in particular, the nature of creation, figuring out when Jesus is coming back, that kind of thing. The actual age of the Earth itself was rarely considered, and when it was evidently strictly in the context of determining the length of the age of men in order to divine the timing of the return of Jesus. Abroad, things were different. In the 6th century and for hundreds of years after, the Sunda kingdom of Java would hold to the Hindu idea that the earth was vaguely trillions of years old. In the 13th century, the Mongol creation stories involved earth divers, chaos taming, and great deities of unknown age. In the 15th century, the Aztecs had the emergence creation story, and to them, the earth was in its 5th creation cycle. The influence of religion on the human perception of time and the very nature of discovery, it just can't be overstated. We're driven by our curiosity to explain the world around us, but we're limited in what we attempt to discover by the context in which we live. If religion and tradition paint the world around you as wild and unknown, or even unknowable, how can science develop? Combined with the challenges of simply eking out a living, it's unsurprising that so few people groups even attempted to put a number to the age of the Earth. It's understandable that there's just a wide variety of thoughts and opinions from people groups through space and time, and that for a lot of people, the age of the Earth could be boiled down to roughly a long time ago, or not that long ago. And as we just saw, early Christian thinkers and really the whole of the Western world was not excused from this phenomenon. Arguments raged as to the age of human history, but as for the age of the Earth itself, people just kind of went, Religions globally gestured at the antiquity of the Earth, but to put a number to it would require a different tool entirely. Science has always been with us as a curious species of ape, and the scientific method is the means by which every discovery in human history has been accomplished, long before it was formalized. Since the first hominid, probably anthropoid, was capable of asking a question like, how might I crack open this nut, the contents of which I know are very yummy, we've been employing a version of the scientific method. Francis Bacon is generally credited with outlining it formally in the West centuries later at the dawn of the Enlightenment in 1620, but it was being utilized long before that. Observation, question, hypothesis, experiment, accept or reject. This little flowchart is how Aristotle was able to suss out that the Earth was not a flat plane, but a globe. Evidently, Brahmic kingdoms of India thought the same around this time. So it seems like people were more interested in this question of what am I on as opposed to when am I, because of the frequency that we see this shape of the Earth question get asked and answered over and over and over again across space and time. The Romans would inherit the Greek science, of course, but this idea of the shape of the Earth specifically would be fleshed out in greater depth at the Baghdad House of Wisdom from the 8th to 13th century. Now, back in the West during medieval times, the shape of the Earth was not particularly controversial. Although, like with Augustine before them, many church fathers were skeptical about the idea that people might live over there. They were cool with the shape of the Earth being a globe as long as the other side of that globe was just completely deserted. However, a new astronomical concept is about to arrive on the scene fast and furious that is going to change science in the Western world and also set the stage for how people would receive other revolutionary concepts about the natural world that are coming down the pipeline hundreds of years later. The Greeks had known that the Earth was a sphere, but both geocentric, where the rest of the planets and the Sun orbit the Earth, and heliocentric, where the Earth and the other planets orbit the Sun, models were clashing. The Western world during the medieval period was firmly geocentric. Everything astronomically revolved around the Earth. This idea was linked to the sentiment held by the Church at the time that the Earth was the center of creation and humans effectively the pinnacle. Science advances when people have the luxury of time. As the Renaissance began to intensify in the 16th century, much as we saw with the Hellenistic period and with the Islamic Golden Age, people finally had a moment to sit back and ask some questions. As previously mentioned, the idea that the Earth might circle the Sun first showed up with the Greeks, but that position was either lost or so unbelievably unpopular in medieval Italy that geocentrism reigned supreme, with no small help from the Catholic Church. Renaissance polymath Nicholas Copernicus challenged geocentrism in 1543, independently deriving a heliocentric model and triggering the Copernican Revolution. Galileo would elaborate on this work with telescopic observations, publishing Starry Messenger in the year 1610. Empirical observations of numerous celestial bodies robustly supported the notion of heliocentricity. The Earth was not the center of the universe. This directly contradicted the official position of the Catholic Church at the time, a geocentric one, and led to the formal prosecution of Galileo by the Church, which might as well have been the government at the time. This wasn't the first time that happened, and it also wouldn't be the last time it happened. 14th century alchemists had been censored by Pope John XXII before Galileo, and Bernard Palissy would be imprisoned for heresy for suggesting fossils were once alive after him in 1588. Almost a century later, Isaac de Peyre of Bordeaux would be seized by the Inquisition for suggesting prehistoric tools were not petrified thunderbolts, but the work of so-called pre-Adamites. France and Italy were not the ideal place for a scientist, primarily due to the fears of the Catholic Church at the time. Case in point, the Church's Index of Forbidden Books would be established in 1559, and it wasn't exactly bereft of scientific tomes. This thing may as well have been a college library.
I kind of hate scientists.
Galileo would continue to work during this Inquisition, publishing on tides, comets, and continuing to support heliocentricity in the face of immense backlash. His work was groundbreaking and would get him formally convicted of heresy in 1633, after which he was sentenced to house arrest until his death in 1642. Then the church banned his books.
Okay. Are you f***ing me right now?
Ew, that could have gone better. Interestingly enough, the church had been okay with Galileo entertaining the idea of heliocentricity so long as he pitched it as a mere hypothesis. Teach the controversy, I guess. Now, the Catholic Church is eventually going to change their mind on all of this, but we're not there yet, so put a pin in it. For the 1600s, the Catholic Church says that everything revolves around the earth, and science says that that century had the Italians looking up, but evidently the British were looking down, and that wasn't the only place they were looking. They were also looking in the Bible. At the very cusp of the Enlightenment, several men would investigate the age of the earth in the most disparate of ways, and it is here too that records finally allow us to get to know our cast just a little bit better. James Ussher was born in Dublin in the late 1500s, and his life sounds a little bit like a Tim Burton screenplay. He was taught to read by two blind aunts who allegedly had the Bible memorized, and graduated from Trinity College at just 16. He would become a powerful archbishop, in part by feverishly preaching against Catholicism. He thought they were the Antichrist.
Please don't dread Armageddon. Antichrist is such a liar. Please don't dread Armageddon. If you take his mark, you'll join him in the fire.
Later in life, however, he became a recluse, spending his time engrossed in research at his home library, walking the rivers by his home, and eating wholesome meat without sauce. Ussher was fascinated by biblical chronology, and his life's goal was to determine when creation actually occurred using both biblical and extra-biblical sources. The earlier John Lightfoot had already published his own thoughts in the immaculately titled A Few and New Observations Upon the Book of Genesis, the most of them certain, the rest probable, all harmless, strange, and rarely heard before, arriving at a creation date of 4004 BC. But Ussher's work would be even more precise. Not long before he died in his late 60s in the year 1650, Ussher's work Annales Veteris Testamenti would place creation on Saturday, October 22nd in the year 4004 BC. Now, Ussher wasn't the only one doing such work, but his ideas prevailed due in part to John Fell. Fell was the Bishop of Oxford, who felt that the next edition of the KJV needed a biblical chronology, a timeline for human history and for the age of the earth. So, when he selected James Ussher's chronology to be released in the 1701 issue of the KJV, that's all she wrote for a while. This Bible was enormously popular, and it put James Ussher's chronology for the age of the earth and for human history in every home. The West had shifted from the infinite world of the Greeks and the Romans to a finite earth, 6,000 years old from creation to present day. However, the natural sciences too were blossoming, and people, even committed men of God, looked down at the earth beneath their feet and felt an enormous sense of unease. In Impossible Monsters, Michael Taylor recounts an encounter Scottish traveler Patrick Brydone had with an anonymous Sicilian bishop who marveled at the archaic lavas of Mount Etna. Quote, Moses hangs like a dead weight on him and blunts his zeal for inquiry. He has not the conscience to make his mountain so young as the prophet makes the world, unquote. Fortunately, Sicilian bishops weren't the only ones looking down. The Renaissance took place from roughly 1450 to roughly 1700, and while a lot of science was carried out during this time period, not a lot of it concerned the age of the earth until the tail end. Still, this is when the stage was set for the movement that would change everything, the Enlightenment. Now, admittedly, the clothing of the Enlightenment is a little bit less comfortable than the clothing that came before. We're not getting to wear a sheet anymore, unfortunately. Things are a little bit frillier, a little bit stuffier, a little tighter in general. But there is one pretty major invention that kind of changes the game in the Enlightenment, especially if you're someone like me, and that's got to be the invention of spectacles. Glasses were invented hundreds of years earlier than that, eh? The edge of the Enlightenment saw the arrival of the gentleman naturalists. These are financially secure men with the time to get an education and the means by which to put it to work, investigating the world around them. Now, there are many early geologists we could discuss as important individuals for the discoveries that were to come, but one group stands apart in my mind as absolutely vital for planting the seed of antiquity in the minds of the scientific world, which was just beginning to emerge, and for a pretty surprising reason. While the battle for biblical chronology raged, geologists with their eyes on the ground encountered one interesting little geologic feature that had them puzzled in their petticoats, and it's one that I suspect every single one of you out there are familiar with. Fossils. Fossils had been discovered and appreciated since the dawn of human civilization, but since the first human laid eyes on them, probably well before that, they'd puzzled naturalists of all varieties. After all, fossils were rocks that kind of look like things that are alive today, albeit not exactly, except instead of being made of bones or hard exoskeletons or some kind of shell, it's made of rock. The debate was pretty simple. Are these rocks that look like living things actually the remains of those living things, or are they just sports of nature? Funny rocks that look like living things but aren't, or rather weren't. Aristotle had remarked on natural processes in Meteorologica and had touched on the nature of terrestrial formations like fossils being the result of vapors and exhalations. Islamic scholar Avicenna elaborated on this idea with his petrifying virtue, a fluid that could turn liquids into solids and may be responsible for many geologic phenomena from stalactites to fossils. And also, human gallstones. Italian physician Girolamo Francesco, ceramics artisan Bernard Palissy, and everyman Leonardo DiCaprio, Da Vinci, I'm leaving it in. Francesco, Palissy, and Da Vinci all thought fossils were once living organisms, using various areas of expertise to explain why they looked the way they do now. However, their ideas found opposition from Enlightenment professor of mathematics, physics, and Oriental studies, Athanasius Kircher. Kircher was not convinced that fossils were once alive and was instead a champion of the idea that they were geologic quirks created by magnetism and the stars. Ironically, Kircher was a sort of proto-diluvialist as well, outlining perceived natural histories of the Noah's Ark story. More people found this convincing than you might think, although I don't know how, but because he argued well enough, this led to a genuine debate about fossils. Were these just sports of nature, or were they once living things? Robert Hooke, hey wait a second, was different. Educated at Oxford, he was much like Da Vinci or Newton in that he dipped a toe in many fields: astronomy, mathematics, physics, chemistry, inventing, architecture, and much, much more. His resume is impressive, but the work he's perhaps best known for is the discovery of the cell in 1665. His text, Micrographica, revealed to the world that big things like us are actually, in all likelihood, made up of a ton of itty-bitty, teeny-tiny things. How unsettling. 3 years later, he would publish on geology with a focus on fossils. Hooke outlined why fossils were once living things, turned to stone over time by some unknown process, in part by pointing out that only some types of organisms seem to fossilize. Today, we know that this type of taphonomic bias is due to a myriad of different factors, including the composition of the organism itself, its rarity, what's going on in that given environment, and so on and so forth. Robert Hooke would also go on to muse just a little bit about the age of the Earth, although he did so quite carefully. This part, being thus covered with other earth, perhaps in the bottom of the sea, may by some subsequent earthquakes have since been thrown up to the top of a hill, where those parts with which it was by the former means covered may in tract of time and by fall and washing of waters be again uncovered and laid open to the air, and all those substances which had been buried for so many ages before, and which the devouring teeth of time had not consumed, may then be exposed to the light of day. Hooke's fellow polymath Steno was a masterful anatomist who became fascinated by fossils around the same time. His text Prodromus pointed out that fossils lack the fracture patterns to have been formed as mere geologic processes, as well as outlining the foundational principles of stratigraphy itself, establishing the law of horizontality, which would set the stage for the law of superposition, which was coming soon. Put really simply, the laws of horizontality and superposition just tell you that layers of the geologic column, and the column is filled with a great many layers that are lower down, were laid down before layers that are higher up, which means that lower layers are older. Both Steno and Hooke also seriously doubted and put this in writing that the fossils of the geologic column could be attributed to a single event, like Noah's flood, something that is particularly interesting because modern creationism demands that that is the case, and because both Steno and Hooke were ostensibly quite religious men, specifically Steno, given his later role as an actual Catholic priest. And yet, they find that by looking at the data themselves, it just doesn't look like a global flood was responsible for the entire geologic column and the fossils therein, or in some cases, it just didn't look like a global flood happened at all. Critically, and this is going to be a big thing moving forward, this did not kill anyone's faith. This simply caused these naturalists to look a little closer at scripture, because they felt that scripture couldn't be dishonest. And so if all of the natural world was saying one thing, then it must be a problem with their, as in humans, interpretation of the Holy Scripture. The work of these naturalists was absolutely immaculate. Truly, it was incredibly convincing to the scientific community. Steno and Hooke are known for their careful scientific inquiry and experimentation and observation and documentation, etc. And yet, this debate still hung in the air. And that's in part because fossils made people kind of uncomfortable. Fossilization as a process is already kind of magical and weird, right? I mean, you've got petrification, seemingly, of a living thing turned to stone. This is fantastic. This is quite literally something that Greek monsters like Medusa did, using magic monstrous properties. And yet, we had all over the geologic column, to the point that any layman could walk around in their backyard in many places and pick them up, animals and plants turned to stone, ones that you could pick up in your hands and roll around and feel with your fingers. This is strange. And stranger still was the nature of the creatures themselves, because while many of them looked familiar, there were shelled things and sort of buggy-looking things and planty-looking things, no one saw these animals around or these plants around anymore. Where were they? Where did they go? Fossils hinted at this prospect that perhaps creatures could disappear forever. All members of a single species, type, or variety could go away and never come back. And this was an unfathomable concept to Christians at the time, who held to a concept called the plenitude of creation. If in the beginning God created everything as very good, including all organisms, why would he allow any of them to go away forever? Were they not brought onto Noah's Ark to be saved from the flood? If not, why not? If so, why after the flood, and how did these animals and plants end up completely stricken from the face of the earth? Did God not want to preserve them? This was a question that was particularly bothersome for another famous naturalist, John Ray. John Ray was very religious, and so in addition to being known as a top-notch naturalist, he was also very well known for combining his theological and naturalistic musings into a so-called natural theology. He actually toyed with the idea that Noah's flood could be responsible for the geologic column, but he came to the conclusion that if it was responsible for any of it, it was a very small part. In Ray's eyes, the geologic column as a whole was simply too astronomically large to have been the result of one single event, even if it were a globe-spanning one. How could the flood explain the deepest specimens? How did it explain the remains that were quite different indeed from modern animals? Ray thought the answer was that the flood couldn't explain these fossils or these features. But then what could? He was, like all scientists should be, comfortable with saying that for the time being, the answer was a mystery. But John Ray's letters hint that in fact, he was partial to a new idea in theology that was currently growing in popularity. This was the idea that the chaos of the early chapters of Genesis may have held vast amounts of time indeed. The potential for large amounts of time in between Genesis 1:1 and Genesis 1:2 among the primordial seas would be formalized by Dutch theologian Simon Episcopius, echoing Aquinas before him, evidently before Ussher's Chronology in 1650. The idea didn't have a name yet, but would eventually become known as gap theory amongst biblical scholars. The actual surge in popularity for gap theory was a while off still, and that's because the Western world at this time was sort of mulling over this bizarre confluence of Ussher's 6,000-year-old chronology and the dawn of modern geology. And these two things happening at the same time in the same place made the following century electric. I also think it arguably induces the rise in popularity of a brand new natural theology, diluvialism. Diluvialism is the idea that the great global flood of Noah from the Bible is responsible for all fossils and perhaps the entire geologic column. Obviously, this idea is familiar to us today because it persists through to modern creationism. They just call it flood geology now instead of diluvialism, its original, much older name. Even during the Enlightenment in the Western world, the Bible was considered the ultimate source of literal truth for at least the history of humans, and it contained a story about an enormous, perhaps global flood. How else is a naturalist of this time to explain marine shells on mountaintops? And yet, as we've already seen, many prolific naturalists are already balking at that idea, at least when considering the data. Still, some, like Thomas Bernet, outlined the flood's official role in geology of the modern world in his Sacred Theology of Earth, published in 1681. In it, at one point, he suggests that the Great Flood of Noah would require over 8 times the water in all modern oceans combined. Where did the water come from? Well, the Earth was created with it in the beginning, Bernet supposed. Where did it go? Bernet didn't know, but he is adamant that we should not appeal to miracles just because we can't find the answer. I hate to pull you out of time here, but can we just take a moment to appreciate how different Enlightenment diluvialism is compared to the flood geologists that we see today working for Ken Ham's Answers in Genesis? Old school diluvialists would have found the modern flood geologists appeal to miracles to solve problems and data that are insurmountable for young Earth creationism in the modern age to be outright shameful. And that's because old school geologists didn't think that creation was deceptive, and they would follow the natural world where it led and use that to help inform their interpretation of scripture, which is always subject to some degree of change by its very nature, because it is humans who are doing the interpretation, even if the text itself is believed to be inerrant. When faced with data that contradicted a young Earth, old school diluvialists would have just abandoned the concept of a young Earth. How do I know that that's what they would have done? Because that's what they did do. More on that a lot later. For now, we can consider guys like Thomas Bernet to be the first flood geologists. And interestingly, some of their models look a lot like some of the models that creationists are still proposing today, albeit a little bit different. Bernays' own work is fairly reminiscent of modern-day Walt Brown's hydroplate hypothesis. A global continent essentially floats on a subterranean super ocean, and the global flood occurs when the crust ruptures. So shockingly to me, and I spend a lot of time reading about what creationists think through space and time, Bernay, the father of flood geology, thought that most of Genesis was actually allegorical. He conceived of God quite literally as a playwright rather than an actor on the stage. And on top of that, he warned actively against literal interpretations of scripture. "'Tis a dangerous thing to engage the authority of scripture in disputes about the natural world, in opposition to reason, lest time, which brings all things to light, should discover that to be evidently false which we had made scripture to assert. We are not to suppose that any truth concerning the natural world can be an enemy to religion, for truth cannot be an enemy to truth. God is not divided against himself." Again, the father of flood geology, imagine that. Naturalist John Woodward formed his own diluvial model, appealing to far more empiricism than Bernay. In his model, the flood destroyed the world before, effectively dissolving continents in the floodwaters and trapping dead organisms inside the mud that remained. This is where fossils come from. However, despite arguing that the flood slurry organized sediment by decreasing specific gravity, he did not support this with observations, and once observations were made, it was clear that the geologic column was not organized in this way in the slightest. William Whiston elaborated on Bernay's original chaos, incorporated much of Woodward's model, and put his own fascinating spin on things. Earth was originally a comet, and also a comet was responsible for triggering the flood. I am not sure how he thought that would work. Winston also found the idea of a literal 6-day creation week to be impossible physically and unfounded theologically. He thought the waters on day 3 would take too long to run off the continents for plants to emerge on day 4, that too much stuff was formed on day 6, and he thought that scripture supported the notion that each day was actually a full year. This is one of the first outlined versions of day age theory, another theological attempt to make sense of the geologic column that argues that the days during the creation week are actually indeterminate periods of time. They may be a year, they may be 1,000 years, they may be millions of years, and that's how they make sense of the geologic column. It's kind of ironic that one of the first formal outlines of what would become day age theory was put forward by one of the first formal diluvialists or creationists. Granted, he thought that the days were actually years, but I must point out again that the point is that other interpretations other than the literal 6 days equals 6 days creation story that we see today have existed since the church has existed. Now, Winston is going to get the heresy bonk from some people for those propositions, but the good news is he did get to end up being Isaac Newton's assistant, so I think it all kind of balances out. The work of another diluvialist, John Woodward, would greatly impact Johann Schuser, an early Swiss naturalist and advocate of harmonizing theology and science. In 1726, he would discover a rather large fossil, which he claimed to be the human remains of a witness to Noah's flood. He would later dub it Homo diluvii testis. So fossils and the origin of geology led to a lot of diluvial discussion. People needed to make sense of this world around them, of this deep geologic column, and of the things entombed within it, which once seemed to have been alive. I have to point out at this point that although there's some of this earliest flood geology that maintains through to the creationism of today, a lot of it is left behind, and the stuff that's left behind is the kind of stuff that would get those fathers of flood geology, like, put to the Inquisition by Ken Ham. None of these guys seem to hold to the young earth creationism that we see today from popular young earth creationists. Some of them thought that vast periods of time were tucked away in the earliest verses of Genesis, but the ones who didn't think that still thought that Genesis should be taken allegorically and that the 6 days weren't actually 6 literal days. That being said, by the mid-1700s, 1750, thereabouts, the general public still primarily held to the idea that the Earth was about 6,000 years old. They're pulling from that Usher chronology that is inside every one of their Bibles in their homes. However, people People had been won over to the idea that fossils were once living things. Fossils represented animals and plants that were alive long ago, and something happened to them to turn them to stone. Incidentally, all this diluvial investigation had involved a lot of fossil collecting, and that meant a lot of looking at rocks. And those rocks had begun to look a bit strange. Early geologists operating in the mid-1700s, such as Giovanni Arjuno, Johann Lehmann, Georg Fuchsel, and Jean-Étienne Guittard, as well as many others, saw powerful and disparate processes at play in the rocks. From mountains and volcanoes to coal seams and rock types, this all could not be the result of a single uniform process, and certainly not a global flood. These men pioneered concepts in geology by observing and characterizing countless formations, as well as coining the very term formations. They built on the work of people like Steno and set the stage for the world of uniformitarianism which was to come. Fuchsel, for example, proposed that only recent depositions were flood rock, and the older stuff must have been formed by ordinary processes. We must take as the norm in our explanation of Earth's history the manner in which nature acts and produces solids at the present time. We know no other way. Guittard's work with volcanoes was even more difficult to square. Ancient Romans had used lava rock with erosive features from an extinct volcano for building, yet no record of what was seemingly an enormous eruption existed. The eroded volcanic rock must have been old to the Romans, and how old, no one could say. Speaking of the Romans, the Catholic Church had been keeping up with the steady march of scientific progress, and they were starting to get a little bit embarrassed. Work continued to churn out, supporting heliocentrism over geocentrism, that the Earth in fact was rotating around the sun and not vice versa. And so in 1758, the Catholic Church quietly removed all heliocentric works from the Index of Forbidden Books. They would keep a much lower profile when it came to arguments about the age of the Earth. They didn't want repeats of past mistakes. Back in Britain, engineer William Smith would connect the dots between the strata of geologic formations and fossils. While documenting coal seams, he discovered that strata could be consistently associated with specific types of fossils, meaning the latter could inform the former, and fossils could thus aid the emerging coal industry, a notion he would publish officially years later in 1796's Smith's Practical Geology, which would revolutionize the field in Britain and unknowingly cement the role of fossils in determining the age of the Earth. All of these geological observations, which were being published and bought up by wealthy gentlemen naturalists, roiled in the mind of Comte de Buffon. Buffon was keeping up with the publications, and all of these rising geological fields seemed to hint at a much deeper past for the age of the Earth. And astronomical observations weren't helping. Isaac Newton had just published on how long comets might take to cool. A globe of incandescent iron equal to ours, that is more or less 40 million feet wide, would scarcely cool off in as many days, or about 50,000 years. Nevertheless, I suspect that the duration of heat is increased in a smaller ratio than that of diameter because of some latent causes, and I wish that the true ratio might be investigated by experiments, spurring Buffon to experimentally test some of these ideas himself. Buffon heated spheres of minerals and timed their length to cool down, determining that Earth was tens of thousands of years old, perhaps even 100,000 years old. He first wrote this up in 1778, arguing that the days of Genesis must be intervals of time. What can we understand by the 6 days the sacred writer designates so precisely by counting them one after the other, if not 6 spaces of time, 6 intervals of duration? In the year 128 AD, Roman legionnaires were building a message. Emperor Hadrian had been divinely commanded to keep the empire intact, and so he decided to build a wall at Rome's northernmost border. The message he would send to all potential intruders: stay out. This is Roman territory. This wall was locally quarried, of course, full of stones that would impart another distinct message some 1700 years later. James Hutton was a medical doctor by training, but he was continually fascinated by the new publications in geology that continued to reach his doorstep, publications which whispered of a much deeper history for the Earth he called home. Eyes glued to the ground, Hutton studied the land of his birth and noticed a discrepancy. Some places were very eroded, while others were not, despite being a part of the same ecosystem. The volcanic rocks of Glen Tilt were worn and weathered, while Hadrian's Wall, whose age was known, was virtually immaculate, despite nearly 2 millennia of exposure. Put simply, Hutton noticed that if Hadrian's Wall was hardly weathered at all, and this structure was over 1,500 years old, whereas Glen Tilt, whose age was unknown, was severely weathered, then however old Hadrian's Wall was, Glen Tilt was far, far, far older than that. Hutton's exhaustive geologic work can be summarized by a single sentence. All of the Earth's formations and features could be explained by everyday processes observable in the present, such as erosion and deposition. The past is key to the present. The exact types of mineral particles found on beaches, riverbeds, and ocean floors could be found in strata at the bottom of the geologic column. These ancient rocks were formed by the same processes at work today, processes which take an unfathomable amount of time. This was why old Hadrian's Wall was in such good condition. Compared to Glen Tilt, it was young. And if Hadrian's Wall was almost 2,000 years old, Hutton thought, how old was Glen Tilt? And for that matter, how old was the oldest rock on the face of the Earth? Again, Hutton's geological work was extensive. It included countless rock types, large ones, small ones, from countless different locations, and it cemented what we now consider to be the foundational concept within geology: uniformitarianism. The past is the key to the present. He would outline this in his seminal work, The Theory of Earth, published in full in 1788. Now, Hutton, my brother, you know that's going to be a heresy bonk, right? Now remember, the vast majority of these geologists that I've just mentioned to you, these early naturalists, were men of God first and naturalists second. And yet, as they looked at the world around them, they realized that it simply didn't look like it was as young as Usher had supposed. And so, as a result of all of this observation, of all of these publications, again by men who were trying to understand God through his creation, people began to look back at their interpretations of Scripture, specifically at Genesis. We can watch this happen historically as the world of science blossoms and discoveries continue to push the age of the Earth into the past. We watch theological developments occur in tandem. We watch as theories from theology like day-age theory and gap theory start to gain popularity in the eyes of theologians and the public alike. Ideas that, remember, had emerged well before the actual scientific discoveries prompted their re-examination. These ideas and a more allegorical reading of Genesis, or at least a more thoughtful reading of Genesis, were not born of science. They existed before the discoveries that pushed people in the direction of a very old age for the Earth. And yet, it is fair to say that these scientific discoveries probably contributed to their rise in popularity and eventually their position as the dominant interpretation of Scripture, at least for a little while. Although, to be fair, the same can be said for Usher's fateful Chronology, which only gained the popularity that it did due to its inclusion in John Fell's version of the KJV. Now, popularity does not equal correct. But popularity does mean greater attention is being given to some idea, and attention often brings scrutiny along with it. Scrutiny which is rarely applied without the precursor of some kind of enlightenment. The world was beginning to look older, but like the religions of yore, current geology still gestured at antiquity in an unsatisfying way. If the agonizingly slow rise of modern mountains was taken backward in time to when the region was flat, one may find themselves hundreds of thousands or even millions of years in the past. And that primordial world, wherever it was shrouded in mystery. Small mollusks surely bobbed in the seas of that bygone age, and perhaps familiar ferns grew placidly supposedly along the steaming coastlines in a world warmer than the one of the Age of Reason. There was hardly time to ask what else may have haunted those misty dead eons before a young woman found an impossible monster. Mary Anning lived with her family at Lyme Regis, a small town in West Dorset where they collected fossils for sale. Like the decades and centuries prior, these fossils were mostly small and familiar things, but people were willing to pay, so Richard Anning took his daughter Mary and his son Joseph with him on regular fossil hunts. Richard would die of consumption when Mary was only 12, weakened from a fall off a cliff 1 year prior, but Mary and her brother continued to haul fossils from the shores of Lyme Regis. One day in 1812, while poking around, Joseph found something extraordinary, an immaculately preserved crocodile skull. Except this skull was unlike any crocodile anyone had ever seen. It was enormous, 4 feet with deep hollow eyes bearing strange rings of bone. Its needle-like snout curved long and horrible into a wicked grin, studded with over 100 teeth. Joseph knew this skull, which had eroded out of a cliff above, must have a body, and so he fetched his sister and they began to search for the remainder of this Stygian crocodilian. They looked for months, feverishly, until eventually Mary, not even a teenager, would herself discover the 13-foot-long remaining body of the supposed Lyme crocodile. This was no crocodile. That much was abundantly clear when this fossil reached the Linnaean Zoological Society of London, who, upon comparing this beast to every animal they could think of, found it resembled none of them. The naturalists of the day found that the closest thing to it was a cave salamander, and so Sir Everard Home declared that the Lyme crocodile was actually to be known as Proteosaurus, a heretofore unknown enormous species of amphibian that had perished in the Noachian deluge completely. This monster was of the pre-flood world, or perhaps native to the great chaos before even creation, but now its entire species was gone, swallowed by the mists of time. What the f***? What happened to the plenitude of creation? How could such a majestic, wonderful, stunning animal, as horrendous and horrifying and scary as it was, go away completely? Did God not say that all was very good at the beginning of creation? Why would he not want to preserve such a marvelous beast? In fact, people were so disturbed by this concept that they went with what Robert Hooke had proposed lightly in his discussions of fossils many years beforehand, that these animals that were showing up in the rocks that seemed to have no modern counterpart, they actually did. We just hadn't found them yet. They lurked in unknown depths or misty faraway continents, just waiting to be rediscovered by us. After all, we had that new world just across the sea. Perhaps that's where all of them were. The problem was Mary kept pulling up fossils. Joseph Anning would go on to get a real job befitting a non-wealthy man of his time, so Mary was left to take the lead. She would crawl those blustery shores with hammer and basket in hand and stare on in awe as a primeval world of monsters opened before her eyes. Anning would collect more ichthyosaurs with their piercing glares and sickled smiles. She would discover plesiosaurs whose long necks and broad paddles defied modern comparison. She found pterodactyls, flying reptiles completely lost to the present age, and she comprehensively documented it all in breathtaking illustration. She sent her fossils to London to be formally described, but her own expertise was nothing to scoff at. Gentlemen naturalists of all stripes from all across Europe visited her at Lyme Regis and consulted with her on the anatomy and classification of these new animals. Despite this, Anning would not be admitted to the Geological Society of London, or even be permitted to attend formal meetings. Regretfully, Mary Anning had a glaring flaw as an early naturalist. Woman. She was a woman. Mary Anning lived at a time where women could not vote, they were not permitted to attend university, They couldn't do most things, and certainly not without the presence of a man beside them. So it's not really shocking that she couldn't attend formal geology meetings, even if she contributed so heavily to them. Instead, much of her work was purveyed academically through her male colleagues. Can you even imagine the frustration? As a woman in science now, over 200 years later, Mary Anning reminds me to be grateful and to be unyielding in my work, regardless of the challenges. I picture her as that Omoledo short film did, scaling the slick, craggy cliffs of Lyme Regis with her rock hammer in hand. I imagine her ragged breaths in the biting winds and her cold fingertips probing over the walls. She's soaked to the bone when she spies it, the great hand of some ancient beast reaching out from a bygone age. Her muddy hands gently play over its own. I can hear her heartbeat quicken as she meets the gaze of an impossible monster unknown to the science she was destined to help create. A gaze that had not seen the light of day for hundreds of millions of years. A dragon's snout, grand and grotesque, roots through the rock, countless needle teeth jutting from its maw as it smiles back at the first paleontologist. Her face breaks with relief and wonder and dread. Her work will not be appreciated as it should during her life, but it will eventually inspire future paleontologists hundreds of years later, 62% of which are women. Buckland was an old friend of Anning's and would formally describe many of her specimens along with William Conybeare. Anning, Buckland, and Conybeare were all foundational figures in geology as well as the blossoming, budding field of paleontology, and all three were fiercely religious, theologians, or even clergymen. Fortunately, the work of Hutton and others, exacerbated by the discovery of marine reptiles, had spurred theologian Thomas Chalmers to popularize Dutch theologian Simon Episcopius's gap theory in 1814, and William Buckland could not have been more on board. Buckland published comprehensive texts on natural theology with a focus on the age of the earth, titled Vindicae Geologiae, or The Connexation of Geology with Religion, explained in 1820. The timing was pretty important on this one. Thomas Paine had just published the final piece of The Age of Reason in 1807, a secular tome that argued that the Christian Bible was no different than any other mythological text. Oh, you better believe this got him the heresy bonk. Neither any of continental Europe nor that weird, scrappy new nation across the Atlantic was hearing what Paine was saying, at least not the public when it came to religion. Paine's other works, including Common Sense and The American Crisis, had been instrumental in triggering the American Revolution and the birth of this new nation as a whole. But while Paine's ideas encouraged and even created deists in the United States, including amongst the founding fathers, the same was not the case over in Europe. People were extremely anxious when it came to non-Christian ideas, and particularly when it came to potentially atheistic ones. You can probably see how new science about the actual antiquity of the Earth felt by many as though they could potentially be weaponized by these non-Christians, by these deists. Not William Buckland. He had something more empirical to stand up to looming threats. He carefully performed a geologic and paleontologic analysis of a Yorkshire cave called Kirkdale, explaining that it was actually a den of ancient hyenas who had lived and died in the cave long ago, but not because of the global flood. Buckland didn't think the global flood hadn't happened, he just thought that some geologic phenomena were more readily explained by processes outlined by Hutton. Buckland argued that science was not an enemy to Christianity or even traditional understandings of scripture, but an ally. His book, Reliquiae Diluvianae, or Observations on the Organic Remains Attesting to the Action of a Universal Deluge, was instrumental for the rising popularity of gap theory, allowing for both an ancient Earth as well as the tales within the Bible. There were still those same lingering theological problems, though, because the hyenas from that cave in Yorkshire, they were gone from the face of the earth, just like Anning's monsters. Where had they gone? Why had they disappeared? Luckily, Buckland didn't need to spend time solving that question because somebody else was already on it. In 1739, an exhausted menagerie of Frenchmen, Algonquins, and Iroquois trudged west of the nascent British colonies. Charles Le Moyne de Longueuil was leading troops on a military expedition across what would eventually be dubbed the Great Land of Ohio, and things were going really poorly. The expedition had been plagued by poor planning. Supplies and morale were both low, leading to the necessity of impromptu hunting trips to search for game to feed these troops. One such trip would be launched while the party was camped east of what would eventually be dubbed the shining city of Cincinnati. And it would be this particular hunt that would set off a domino effect that lasted a century, eventually culminating in one of the most important concepts in all of paleontology. The men smelled the great sulfuric marsh before they saw it, following their noses and a faint line of buffalo tracks to a sprawling flat of mud, steaming and studded with thousands of bones. Some of these bones towered out of the mire like enormous scythes. The men returned to their boss with what must have seemed like the remains of a monster or Nephilim, an enormous femur, a great curved tusk or fang, and countless brick-sized teeth weighing 10 pounds apiece. This was nothing like anything the men had ever seen before. No animal of this size roamed the valley, not even in the cultural memory of the indigenous folks among them. So Longueuil did what any good leader of an emaciated party would do. He had them haul the remains for hundreds of miles to New Orleans so that they could eventually ship them back over to Europe. The remains would be housed with another so-called giant's tooth, and together they defied categorization. The femur and tusk were clearly proboscidean. There was some kind of American elephant, but the tooth looked nothing like modern elephant teeth. Extant elephants have teeth that are so extremely lophidont in nature that they are considered loxodont, but these teeth looked like primate molars. Human molars, even. Maybe they did belong to a giant. Our old friend Comte de Buffon thought that whatever the teeth belonged to, that animal was bigger than whatever the elephant stuff came from, and that perhaps that animal, the mystery animal, was the only creature to ever disappear completely from the face of the earth. And believe it or not, ever the Francophile, Thomas Jefferson was plugged into this debate, and he was fascinated by it. Jefferson thought the animal must have been 5 or 6 times the size of modern elephants, probably carnivorous, and in his opinion, was still out there. This is perhaps the most striking example of just how unthinkable the idea that an animal could completely disappear was. A giant carnivorous monster that may still be lurking in the American West. Jefferson was so sure of this, he eventually told Lewis and Clark to keep an eye out for the beast. I have to imagine that Sacagawea was like, okay.
Not really. Maybe. It's classified.
But rising star George Cuvier had seen teeth like this before. An enormously successful naturalist already, Cuvier had worked with ancient elephant bones from Siberia that, while they were some kind of elephant, were also different from any living elephant due to the unique characteristics of the teeth and jaws. These new bones from Ohio were even more diverged from the modern elephant, leading Cuvier to report in a lecture in 1796 that both the Siberian elephant and the Ohio elephant were unique from modern proboscideans, and that both were a species perdus, lost species, gone forever, extinct, and they weren't the only ones. This was not popular right away, and in fact, Jefferson was vocally against it. He remarked, "Such is the economy of nature that no instance can be produced of her having permitted any one race of her animals to become extinct, or of her having formed any link on her great work so weak so as to be broken." He really wanted there to be mammoths. Cuvier had received the remains of a 12-foot-tall, roided-out super sloth from South America a few months earlier. Megatherium, the great beast, which no one had ever seen alive. It too must have gone extinct. So now people are starting to think, how many animals had disappeared forever from the face of the earth? Why had they vanished? By the year 1800, Cuvier had over 20 extinct species cataloged, Irish elk and cave bears and pygmy hippos and more. But notably, Almost all of these extinct animals had modern counterparts that looked like them, at least in some way. This would change for the radical in the year 1808, when Cuvier would receive in the mail a drawing of a fossil that had been found some 2 decades earlier in Germany. The fossil drawing had come from a one Johann Hermann, who thought that maybe he'd found some kind of weird aquatic mammal. Cuvier took one look at it and he was like, this does not look like anything I have ever seen. He dubbed it pterodactylus, or long finger. Cuvier must have felt like a cryptid hunter, because this was not the only bizarre animal that he would receive word of. Within a year, Cuvier would get a look at a skull from the Netherlands belonging to the so-called great animal of Maastricht. It had been discovered decades before in the inky black belly of a chalk mine. In those subterranean depths, workmen had an experience much like Anning's when the jaws of a great, impossible monster yawned from the earth. No one knew what this creature was, and while it made a splash initially, it would be decades before its identity would be revealed. Originally thought to be a whale and then a crocodile, Cuvier recognized that this creature too was like nothing that currently lived. These animals were odd, but most of them were one-offs, especially the ones without modern counterparts, so they were easy to write off as mysterious, but exceptions to the rule. That is, until a small family out of Dorset in Britain just continued to add to this list of relict creatures. Joining that list was Schuster's flood victim Homo deluvii testis. Cuvier correctly determined that this was not actually a human, but an enormous salamander, which was lost to the modern world. An honest mistake, as Wikipedia notes that the fossil, quote, could be interpreted as showing some resemblance to the remains of a violently trampled human child, unquote. Huh. What a weird thing to say. From Cuvier's collection and Anning's collection, as well as the countless additional fossils coming from every which way, it seemed as though extinction was the fate of many enigmatic animals through space and time. They also seem to keep popping up in clusters, as if killed off by the same thing, some kind of big catastrophe. Or was it catastrophes? Cuvier outlined his idea formally. The Earth had been ravaged by numerous distinct catastrophes, each of which had caused mass extinctions of the life living at that time, and each of which was followed by the succession of the world by a new group of animals. He called it catastrophism. Anning's strange reptiles did not live alongside the mammoths or mastodons or great sloths. They ruled a world all their own in the age of reptiles. Hutton had shown the Earth was probably quite old, and Cuvier organized and populated its far-flung epics. Cuvier's catastrophism was distinctly not in line with a single global flood. His was a series of disasters over vast periods of time, not unlike what Comte de Buffon had sort of softly pitched decades earlier. Still, William Buckland could work with this. He would end up synthesizing Cuvier's catastrophism with Genesis and the Noachian deluge. The Noachian deluge was a catastrophe that had caused a mass extinction, but also the Earth had been around for a pretty long time. You know, in the beginning, writhing abyssal leviathans met titanic terrestrial behemoths in the 1820s with the discovery of the dinosaurs. Thanks to Cuvier, William Buckland was re-examining giant's bones. He received a partial jaw from John Kidd, and with Cuvier and William Conybeare, realized it belonged to another great gone creature. Additional remains from the Stonesfield quarry allowed Buckland to see the animal for what it was, and the fearsome Megalosaurus, the first non-avian dinosaur named, would enter the scientific community in 1824. 2 years earlier, Gideon Mantell, inspired by Anning's discoveries in Dorset, had gone fossil hunting himself. In 1825, he would officially name another enormous terrestrial reptile, Iguanodon. William Buckland would have enormous success marrying the global flood with these antediluvian monsters, but that would change, and part of it was due to art. The global deluge had already been in the center of culture as much as it was in the scientific community. The Deluge by Joseph Turner drew large audiences, accompanied by words from John Milton's Paradise Lost from centuries earlier. The poet Lord Byron wrote Cain, a Mystery, in 1821, in which Lucifer shows Cain the antediluvian world and the beasts which dwelled within it before being swept away by the events outlined by Cuvier's catastrophism. Sometimes the flood was responsible for extinction, sometimes an unknown event, but always these primordial monsters ruled long ago. Soon the flood would disappear from the narrative as time stretched further back. Marine reptiles and pterodactyls appear in art like a more ancient Dorset, and awful changes. Alfred Tennyson decades later would invoke dinosaurs in his own work, In Memoriam, depicting the violent eons before man. Art of the flood, the antediluvian monsters, or both would permeate this century, leading to some of the most atmospheric works of art ever created. Mario Lanza is a modern-day science communicator and artist who captured this period of time in breathtaking detail in his short film, Antediluvian. The known pre-flood animals of the Enlightenment wallow and clash in the twilight of this primordial world. Ichthyosaurs, plesiosaurs, ammonites, pterodactyls, and the great dinosaurs tear into one another in the chaos before being swept away by an unfathomably large flood. It's haunting. Cuvier had brought two huge concepts to the 1800s, catastrophism and extinction, both gorgeously depicted by Lanzas. So Cuvier thought that the Earth was very old, in part thanks to the work by James Hutton, but Cuvier did not buy uniformitarianism. He didn't think that slow, gradual processes could be responsible for the geologic column and its contents. No, that required catastrophes. They were spread over long periods of time, but they were quick and violent. This would be the debate by gentlemen Christian naturalists from this point forward. The Earth is vaguely quite old. How old? We're not really sure, and at least some of that geologic column is due to the global flood. Right? Not really. Surprisingly, some of the best and most exhaustive arguments about the role of a global flood, or even a global flood's existence at all, came from Christian naturalists. For example, John Fleming was a Scottish biologist and minister who took issue with Buckland's model almost immediately, boldly calling it unscientific and frankly unbiblical. It didn't match the flood described in scripture, and neither could explain the formation of gravels and caves, according to Fleming. Cuvier wouldn't make it out of all of this unscathed either, as a rising geology star and William Buckland's own student had been considering catastrophism and found it lacking. Charles Lyell knew Cuvier through Buckland, his mentor. By the 1820s, he was a scholar in his own right and had embarked on an expedition with gentleman naturalist Roderick Murchison and his wife Charlotte, who was a naturalist in her own right. This expedition was cross-continental and would take Lyell through the forests of Auvergne and across the Italian Alps, observing and discussing countless observations with his companions. In Naples, at the crumbling ruins of the Temple of Serapis, he would have his epiphany. The excavation of the columns of the Temple of Serapis had revealed a curious pattern. As Michael Taylor recounts, quote, "The top third of the columns were weathered, and the bottom thirds smooth and uninjured, but their middle sections played host to dozens of cavities made by bivalve mollusks known as lithophaga, literally stone eaters. But what could explain this pattern? Why was there evidence of a shoreline so high above the ground? For Lyell, only one chain of events could explain it. First, sometime after the columns had been restored under the Severan dynasty in the 3rd century AD, the lower part was covered up and protected by strata of tuff and the rubbish of buildings. This would explain why there was no evidence of weathering or erosion at the bottom. Second, there must have been a long continued immersion of the pillars in seawater, which alone could explain the action of the mollusks in the middle third. Finally, after remaining for many years submerged, the pillars must have been upraised to the height of about 23 feet above the level of the sea, allowing for the weathering and their discovery by modern Neapolitans. In other words, the level of the land on which the temple was built had changed repeatedly in relation to the level of the sea. For Lyell, it was proof he could rescue geology from the restraints of Genesis. He could free the science from Moses, unquote. Lyell's work would inspire countless scientists and artists alike, including the poet, as previously mentioned, Alfred Tennyson, who wrote about uniformitarianism and catastrophism and dinosaurs and extinction in his famous poem In Memoriam. Principles of Geology would also make it into the hands of French antiquarian Jacques Boucher de Crevecoeur de Perthes, who, when poking around the Somme River, stumbled across Ice Age hand axes. These hand axes were very old, although how old he didn't know, but they were certainly created by the hands of man. Initially, he was content to assign them to early people from after the Great Flood, but closer examination pushed him to a greater antiquity. These were antediluvian. Similarly, Philippe Charles Schmerling would very nearly make history if he hadn't gone broke first. Schmerling was excavating Angus Cave alongside the River Meuse in Belgium when he discovered artifacts from some unknown ancient people group, along with 2 skulls. One of these skulls belonged to a human, and the other belonged to something else entirely, although no one knew it at the time because the skull belonged to a child. Schmerling wanted to publish, but he couldn't afford to pay for the printer, so his work effectively languished in obscurity, ending up in storage at the University of Liège upon his untimely early death. Charles Lyell, a deeply religious man, documented innumerable formations in his seminal work Principles of Geology, which was fully published in the year 1830. Lyell detailed how geologic structures are continuing to change today and explained their formation within that context. He deftly argued that we need not invoke exotic one-off events to explain the geologic column. Rather, as Hutton had proposed, processes we observe today are demonstrably responsible and have left their mark ubiquitously. Lyell, with the help of Fleming, pointedly did not suggest that the flood of Noah did not happen, but rather that it was a strong local inundation in the Middle East. Lyell's work truly revolutionized geology and would go on to impact every single subsequent naturalist. Astronomer and mathematician John Herschel would concur with Lyell, remarking, time, we must not impugn the scripture chronology, but we must interpret it in accordance with whatever shall appear on fair inquiry to be the truth, for there cannot be 2 truths, and really there is scope enough, for the lives of the patriarchs may be reasonably extended to 5,000 or 50,000 years apiece, as the days of creation to as many thousand millions of years. Herschel was a day-age theorist, much like American naturalist Benjamin Silliman, who reconciled the consistency of geology with the sacred history in his premier book on geology, Introduction to Geology. The most prolific naturalists as the 1820s drew to a close, particularly the geologists, seemed to abide by day-age theory generally, including Arnold Gouillet, John Dawson, Hugh Miller, and Dwight Dana. This is in no small part due to the incredible work and accompanying reception of Lyell's Principles of Geology. George Cuvier would die before Principles of Geology was published in full, but William Buckland would read the entire thing. In 1836, Buckland published the famous Bridgewater Treatises, a series of essays commissioned specifically to display the power, wisdom, and goodness of God as manifested in the creation. Among the authors were gap theory's Thomas Chalmers, who raged against materialism's attempts at cornering the markets of science, but Buckland used his essay to acknowledge that the biblical account of Noah's flood could not be supported using geology.
By the 1840s, Buckland was fully on board with uniformitarianism,
and hand in hand with the next generation of geologists. Professor of geology at Cambridge, Reverend Adam Sedgwick, and a big fan of Buckland's original diluvial work, argued that Charles Lyell had been too quick to suggest that processes stronger than those we see today, such as a global flood, could not be at play in the creation of the geologic column. He would recant this opinion by 1834, probably in no small part because of Buckland's own 180 after reading Principles of Geology. All of these men, and indeed many more, are excellent examples in displaying just how well Charles Lyell's Principles of Geology, and of course the old earth that was necessitated by it, was received by the other Christian naturalists of his day. There were some holdouts. In 1833, George Young, a self-described scriptural geologist and pastor, penned Scriptural Geology, a 79-page volume arguing for Cuvier's catastrophism and a young Earth. This book echoed George Bugg's earlier 1829 sentiment in a longer book of similar but longer name. Scriptural geology, or geological phenomena consistent only with the literal interpretation of the sacred scriptures upon the subjects of the creation and the deluge, in answer to an essay on the theory of the earth by Cuvier and to Professor Buckland's theory of the caves as delineated in his Reliquiae Diluvianae.
Yo, get a job, work a 9 to 5.
Meanwhile, Adam Sedgwick, now a firm Lyell enjoyer, would lash out at this type of text. They have committed the folly and sin of dogmatizing, having sinned against plain sense and of writing mischievous nonsense. Their eyes cannot bear to look upon truth and suppose an ignorant and dishonest theory. They show bigotry and ignorance of nature's laws and natural phenomena. American minister Henry Cole would swat back, calling Sedgwick's ideas unscriptural and anti-Christian, while other naturalists sought more philosophical answers. Philip Goes in 1857 would propose Omphalos, an attempt to untie the geological knot. This text argued that just as Adam was created with a belly button, a navel, despite having no mother or history of birth, so the earth was created with the illusion of age. Fossils and formations were put there at the beginning of time, which was still 6,000 years ago. The earth did look old, but that wasn't because it was. Goes was slammed for this idea, which basically proposed a divine trickster was out to deceive mankind instead of abiding by his own scriptural and natural laws. Goes obviously refrained from discussing much geology itself in the text, despite the title, because he was a marine biologist. You may have noticed, actually, just how few detractors by the 1860s were actually, geologists. And the books and pamphlets by these detractors were fast becoming drowned out by what was a veritable flood of conventional geology. In 1840, American geologist Edward Hitchcock wrote Elementary Geology, and the following year, Scottish Hugh Miller wrote The Old Red Sandstone in 1841, both books being an everyman's guide to geology that argued that an old Earth proclaimed God's glory more than a young one. These men would continue their crusade over the decades as well. In 1851, Hitchcock wrote The Religion of Geology and Its Connected Sciences, which argued that religion need never fear science because scientific proof is religious proof. The Bible was not meant to explain nature. Miller would write The Testimony of the Rocks in 1857, in which he insists on day-age theory and a local flood before predicting that, and he uses this term, anti-geologists like the young Earth creationists of his day would eventually be as common as geocentrism or flat Earth.
Ooh, yeah.
My source on this argues that Miller was wrong on his prediction because there actually are more young Earth creationists still than there are flat earthers, but my source is from 2009, so it turns out Miller was right, just in a kind of monkey's paw sort of way. As the decades ticked on, young Earth creationists, the diluvialists, all but vanished from the halls of science. Formation after formation was described, the processes that formed each one slow and plodding in the present. Local catastrophes like earthquakes and volcanoes left their mark on the rocks too, revealing to geologists what a global catastrophe should look like and leave behind, the mark of which was completely absent in the vast and growing geologic column. Even more great extinct beasts emerged from the stone, organized by stratum across the entire globe but unified by no one geologic event. Some died in dry deserts, others on tranquil coasts. No sign of a global flood emerged, despite the best efforts of the waning scriptural geologists who now had to rely on their biblical interpretations alone, and time marched deeper and deeper into the misty millions of years before present. Then, in 1861, after Hutton's initial proposition, Lyell's seminal work, and the contributions of countless geologists over the decades, the president of the Geological Society of London addressed a crowd of gap theorists, day-age theorists, and naturalists of faith and lack thereof alike. Leonard Horner spoke of his own work and the work of the members of the audience concerning geology and archaeology, arguing that it has, quote, been gradually producing an impression in the minds of the earnest thinkers that the first appearance of man on the earth must be carried far beyond the time hitherto usually assigned to it, unquote. This was well met by the geologists in the audience and the ones not in attendance of that time because no one was publishing anything serious with regard to a young Earth. But Horner took it one step further. The scientific community knew this, yes, but the general public did not, and this was in part because of the Ussher footnote. Not only was this untrue scientifically, but young people who grew up learning it would be confronted with the facts of geology and they would be confused. Their faith in God or in science would be strained. There was only one solution. Ussher's reference needed to be removed. Quote, "It is untrue and therefore it is mischievous," unquote. It would take some time, but some half a century later, in the year 1909, gap theory and date-age theory would be included alongside the Ussher chronology in the Schofield Reference Bible, which would be even more popular than the original Ussher KJV version. In the year 1862, Lord Kelvin used the tenets of thermodynamics to argue that, due to the time taken to cool, the Earth must be hundreds of millions of years old, the oldest date yet. By this point in time, Ussher's chronology is long gone from any major natural theology, and for good reason. It had had its day in court, and it had been found to be inadequate. For decades, a young Earth and a big global flood were assumed to be reflective of reality in the Western world. These ideas were the default. And because of that, those ideas were taken seriously, and they were scrutinized as real ideas that may be reflective of reality. And they were found to not be capable of explaining anything in the geologic database that they'd accrued at the time, let alone everything. But you may have noticed those facts killed young Earth creationism, diluvialism of that time period, not Christianity, and that's because the majority of the scientists doing the work to show that the Earth wasn't actually very young as Ussher conceived, those scientists were Christians. And these discoveries within the geologic world didn't prompt them to throw away their faith. It prompted them to look at other scriptural interpretations that were copacetic with the observations they were now making, interpretations that existed prior to those geologic observations. Put simply, Enlightenment era science and onward didn't prompt theologians to make up a new way of interpreting Genesis. It simply prompted them to look at the interpretations that already existed and pick one that made more sense. Just like, by the way, they did when heliocentrism was shown to be an accurate representation of our solar system as compared to geocentrism. There was precedent for that too. All of this thanks to the work of early church fathers, Simon Episcopius, countless pre-Enlightenment naturalists and theologians, the early diluvialists, Thomas Chalmers, James Hutton, George Cuvier, Mary Anning, William Buckland, John Fleming, and Charles Lyell, among countless others. By the mid-1800s, young Earth creationism was dead from a scientific perspective and totally unreasonable from a theological one. And the global flood fared no better because these same geological observations were running quite contra to the expectations for a year where the world was underwater, and during that year, all of geology happened. The Noachian deluge was found by these geologists to be fundamentally unable to account for the hundreds of millions, if not billions of years of processes, many of which required opposite conditions than are present for the flood, or unique conditions which it would have precluded. Desert formations like evaporites, preserved sand dunes, and red beds all exist today, and they're still forming today, requiring dry, arid conditions and millions of years of time. Fossil forests exist, stacked on one another, but still rooted in place place with regenerative growth signs like ancient cities built on the same ground, the result of consistent ecosystems across vast time spans. Resources like coal, natural gas, and oil require millions of years to form in the numbers we see today, and anyone who says otherwise should chat with the energy industry. Sedimentary rock exists in enormous layers, thousands of feet thick, formed over millions upon millions of years. The sheer amount has been mathematically shown to preclude a global flood. It physically cannot dewater in time to support the weight of animals, let alone cities, after the deluge. Deep shales with iron oxide formed through contact with open air above sea level deny an underwater formation, and the magnetic field's hundreds of reversals cannot be crammed into a single year. Limestone, with its calm and warm water prerequisites, could never accumulate thousands of feet high in a global flood, and ancient coral atolls reveal a history older than the young Earth creationists' universe. Ice cores, tree rings, and humble varves, too, not only preclude the flood in their record of the seasons hundreds, thousands, and millions of years ago, but corroborate one another in their timekeeping. Hundreds of craters as well pockmark the geologic column, each impact capable of regional or worldwide destruction, which would alone require hundreds of years for the Earth to recover, and together would fracture the Earth in twain. Even the calcite locked away in forgotten caves a world away from one another record the steady and ancient precession of the Earth's wobbled orbit around the Sun. Each of these processes or features independently indicate an ancient Earth, with many of them corroborating one another on specific times, a statistical impossibility, if not reflective of reality. The Earth is old. And so, by the mid-1800s, young Earth creationism, diluvialism, was well and truly dead from a scientific perspective. But, as we know, scientifically dead does not mean gone. Otherwise, we wouldn't be dealing with flat earthers in the present day. As it happened, the corpse of young Earth creationism, of diluvialism, had been hidden away in a little church all the way over in America, waiting to be resurrected by a prophetess named Ellen G. White. But before we can discuss the metastasis of old diluvialism, now creationism, over the Atlantic to America, we need to discuss the reason for its revival. A concept that would inadvertently and completely inconceivably contribute to one of the largest surges of anti-intellectualism in the history of the United States, as well as the rise of the religious right. Our story is a little more complicated than perhaps I initially led you to believe, because as it turns out, an ancient Earth is one thing, but threatening human exceptionalism, white supremacy, and the social order as we know it, that's another. I'm not kidding about that. That's not an exaggeration. You know how sometimes major historical events are weird to consider, like on the same timeline? For example, I stole this one from Reddit. Thank you, u/lastkill, but did you know that the inauguration of the Eiffel Tower and the Wall Street Journal,
Starry Night by Van Gogh,
the origin of Coca-Cola and Nintendo, and the birth of Adolf Hitler all happened in the year 1889? Well, the technological and industrial revolution was happening concurrently with slavery. Half of these nerds that I've been talking about and will talk about were abolitionists. The publication of the first hadrosaur was delayed due to the onset of the Civil War. All of time is connected. We are linked to one another by the black thread of fate under the simple guise of cause and effect. Nothing is without consequence, and we all exist within the context of our own There was a moment in some far-flung past when the first human, or more than likely the first hominin, looked down at their feet or up at the stars and asked, "How long has this been here?" It seems reasonable, intuitive actually, to suggest that shortly afterward, maybe moments, that same ape looked at their hands and probably with wonder asked, "What am I?" Humans are weird. That much is obvious. No other critter has really considered itself quite like we have, and we've been doing it for a long time. Some of the earliest cave art has us representing ourselves, sometimes alone and sometimes with other critters. Some of these older religions would have humans as united with the rest of the natural world, but By and large, I think it's fair to say the majority of religious perspectives had humans as created alongside the rest of life on Earth, but unique compared to it. And I think this is kind of a fair perspective for the people at the time. We were the only ones who were spreading out, who were inventing new tools in cities, evidently, and of course, we were the only ones asking such questions. But exceptions notwithstanding, it kind of seems as though once society set in, most human religions or philosophies considered our species to be like other living things, but distinct in some kind of ethereal way. The nature of that distinction was unclear, as evidenced from the myriad of different perspectives depending on the society in question. But this idea of what are we and how do we actually fit in with all other life on this planet clearly gnawed at us more than how old was the Earth. While no doubt this was a question we'd been asking since we could first form a thought, it was the Greek philosopher Anaximander who first formally proposed that animal types, including humans, could change over time. He proposed that humans had descended from fish, metamorphosing from them when their marshy habitats dried up. This would be the first naturalistic origin suggested for humans in the West. The gods were nowhere to be found, although in a world of metaphysical paradigms, Anaximander knew he was fighting uphill. Materialism, or the idea that the world is composed only of physical matter and its interactions, would be proposed as early as just a few decades later with Democritus. In fact, he and his teacher were the first to propose that the world was made up of individual units, tiny, imperceptible to the eye, called atoma, and that all that occurred in the universe was due to chance and necessity, rather than the actions of the gods. Those ideas would influence the much more popular Epicurus, who believed that nothing should be believed unless it can be supported via observation and deduction. Less of an empiricist was Aristotle, yes again, in the year 400 BCE. Aristotle saw design, where Democritus and Epicurus saw chaos. Aristotle devised the Great Chain of Being, or Scala Natura, to conceptualize humans and the rest of the world. The Great Chain of Being organized things, with humans fitting snugly between the lower animals and the gods themselves. This was popular, for obvious reasons. We're humans, and we're better than other animals. Aristotle had been a student of Plato, who saw the world as variations on ideal themes. Essentialism proposed that things have a set of unchanging characteristics that makes them what they are, and variation among things is an unimportant deviation from the essence. Man's essence was, famously, that of a featherless biped. Diogenes, another student of his, is said to have famously plucked a chicken and declared, "Behold, a man." The perceived reduction of humans to this definition obviously rubbed some the wrong way, which is why some form of human exceptionalism is how we generally conceived of ourselves from the time of the Greeks all the way up, effectively, until the Enlightenment, rather than Anaximander's fishmen or Diogenes' jests. Some accepted that we were animals, although this wasn't the norm. Even then, though, we were always exceptional animals. We had something divine about us, a soul or some kind of design implemented by the gods themselves, bringing us higher up than the rest of life here on the planet. And critically, it had always been that way. The Great Design, as outlined by Cicero in 45 BCE, necessitated this. You could not get what we were from anything prior. So outlined the Great Chain of Being and Essentialism alike. All organisms, including humans, were and had always been as they were now. So necessitated Essentialism and the Great Chain of Being. And that's where things stayed for a long time. At least in the West. Abroad, things were different. Zhuangzi, prior to the Common Era, was a Taoist philosopher from China. Taoism differed from Western philosophies and religions and viewed humans as a part of nature, with both being in a constant state of transformation. This allowed species to develop features that were related to their environments. During the Islamic Golden Age, Nasir al-Din Tusi mused on variation. He thought that animals seemed to adapt to their environments and proposed perhaps humans were an adapted form of some previous animal. Ibn Sina would describe fossils formally as well and discuss petrification in the year 1027. Ibn Khaldun saw the similarities between humans and other primates, arguing that humans came from, quote, the world of monkeys, unquote. I don't think it's a coincidence that places that saw the connection between humans and other animals, particularly other primates, were always locations that had monkeys living there. It's just easier to see the connection when you're looking at animals that behave so similarly to us, or rather, perhaps we behave so similarly to them. Conversely, it seems that human exceptionalism was inexorably linked to places without monkeys or other primates, and this makes sense too. It's a lot easier to draw the line between humans and other animals when you're missing any of our closest living relatives, with which to draw comparison to. Back in the West, various thoughts on the human place in nature emerged, but all had the unifying theme of humans as set apart from nature and as unchanging units, particularly due to the dominance of Christianity and the themes of Genesis. One could argue that much of biology in the West was stagnant during the medieval period and for most of the Renaissance, in stark contrast to the advances of astronomy and the burgeoning discoveries of geology. But the Enlightenment would set the stage for the biological revolution, because just as those geologists and astronomers were asking questions about the rocks and, the sky, biologists were beginning to ask pivotal questions about the nature of living things. Our part, of course, was more or less set in stone, both in the Western world and abroad. Humans are special, we're created by God in His image, and nothing changes anyways, so that's how we were, and that's how we would always be. But there were still plenty of things to investigate about the natural world at large. How did we consider and regard all these other creatures with which we shared the planet? In the year 1680, British anatomist Edward Tyson cut up a porpoise, and he noticed something odd. People had recognized before that whales and dolphins were different from many other marine animals. They didn't have scales, they seemed to breathe air, and anecdotally they seemed smarter. But the human understanding of the animal kingdom at this time was very much static and discrete, something this dissection would disrupt. Tyson found that internally, porpoises looked far more like land animals than marine animals. There were many similarities, but the most striking was the forelimb, which resembled the forelimb of land creatures, including that of man, and a brain which was phenomenally complex, also resembling that of man. Whales and dolphins, the cetaceans, were not fish, they were mammals. Tyson, who would become known as the father of comparative anatomy, would outline this in a publication, but he wouldn't group cetaceans with mammals, because the word mammal didn't exist yet. And this would set him on a course of investigating more animals and their similarity to man. In 1699, Tyson published The Anatomy of a Pygmy, this being the name for a chimpanzee at the time. In this text, he aimed to compare chimpanzees to monkeys and to man by systematically dissecting and describing the external features, muscles, organs, including the brain, and bones of each. In this tour de force, Tyson found that chimps, that is to say, apes, resembled humans in 47 respects, compared to a mere 34 respects that they shared with monkeys. Most surprisingly, the brains of humans and chimps differed not in structure, but in size, an observation which led Tyson to conclude that the image of God was found in the rational mind rather than the physical brain. Tyson's work was not controversial, in part because he was just reporting observations, but his work would go on to influence the most prolific naturalist of the 1700s and would lead to a much splashier statement on the connections and similarity between man and ape. Carolus Linnaeus was a Swedish physician who, like most gentlemen naturalists, dipped a toe in basically everything else. Linnaeus is probably best known for completely overhauling and organizing the way we classify and consider all life. He called this Systema Naturae, and today we know it as taxonomy. You know his system already: kingdom, phylum, class, order, family, genus, species. Distinct and nested ranks that allow organisms to be binned and understood. In 1735, Linnaeus published Systema Naturae, a way to categorize, order, and name life. Linnaeus was highly religious. In fact, the invention of taxonomy was rooted in a desire to organize God's creation, a blessed quest. As such, the categories, including the species level, were fixed and unchanging, the same now as they were in the Garden of Eden. Genetics obviously didn't exist yet, so the way that these categorizations would work was on the basis of physical characteristics, on the basis of morphology, and each category sequentially nested organisms into more specific bins, with the kingdom being the broadest and the species being the most specific. Obviously, across Linnaeus's quest to categorize all life, he ended up having to place humans somewhere. And just as Edward Tyson had found, Linnaeus noted that humans were incredibly similar to things like chimpanzees, leading him to place humans and the other apes together in a group he called anthropomorpha. That name means shape of man, so what he's doing is he isn't denigrating humans to the place of other animals, but he's rising some specific animals, the apes, up to the level of man. At least at that category. Humans obviously still had our own divinely unique species. Ernst Haeckel, who would become a fierce ally of a young naturalist we'll meet here soon, called it, quote, the most important sign of Linnaeus's genius, unquote. Linnaeus would receive some criticism for this, but he was a world-renowned naturalist who had reached this conclusion through many careful dissections of innumerable species. But he was aware of how it went over, putting humans and apes into the same category. He wrote once in a letter to Johann Georg Gmelin, "It does not please you that I've placed man amongst the anthropomorpha, perhaps because of the term with human form, but man learns to know himself. Let's not quibble over words. It would be the same to me whatever name we apply, but I seek from you and from the whole world a generic difference between man and simian that follows from the principles of natural history. I absolutely know of none. If only someone might tell me one single one. If I would have called man a simian or vice versa, I would have brought together all the theologians against me. Perhaps I ought to have, by virtue of the law of the discipline." I love Linnaeus's response here, because he's essentially saying to the rest of the scientific community, okay, well, if I'm wrong, then tell me why. And no one could. The truth was, people were simply uncomfortable with the idea that other animals could be considered in the same group. In this group, anthropomorpha, that these other apes could bear the image of man, the image of God. Linnaeus was strongly religious, and he stood firm. Humans were, physically at least, animals. One should not vent one's wrath on animals. Theology decrees that man has a soul and that the animals are mere automata mechanica, but I believe they would be better advised that animals have a soul and that the difference is of nobility. That's just so cool. Linnaeus is so cool. Eventually he's going to change in one of his later editions the name anthropomorpha to the more familiar name we know today, primates. He's also going to officially create the category of mammals, allowing Tyson's cetaceans to find a home, an explicable categorization at last, as marine mammals. Always though, Linnaeus was insistent. Humans are animals and humans are primates. Our soul is what makes us distinct. For all his brilliance, however, Linnaeus was still a man of his time and thought no species were actually related to one another. Not lions and cats, not wood ducks and whooper swans, not Agonum antenarium and Agonum carbonarium. So the similarities of humans and these other man-like simians meant only that they shared a common design. Linnaeus's enormous influence cemented his system as the means by which we discuss organisms all the way up to this day. But an unintended consequence of this is what came with that system was the concept of species fixity. The idea that these species are discrete units and that species don't really change very much over time. One particular bulldog for species fixity was our old friend George Cuvier. And I say bulldog because he had an opponent. Jean-Baptiste Lamarck was a college dropout who joined the military to fight in the 7 Years' War. He fell in love with the natural world, returned to school, and found himself as a professor of zoology at the French Natural History Museum. Like many naturalists, Lamarck was keenly interested in the variation of life and how perhaps life had changed. Discoveries supporting the immense geological change over time, namely erosion, led him to propose not only that species changed, but that the environment may be responsible. He pointed to blindness in moles as an example. These animals were superficially similar to many rodents, but lacked eyes and lived in the dark. Perhaps they lacked eyes because they lived in the dark. Now, Lamarck was not the only early naturalist to propose this idea of the transmutation or change of species over time. One earlier such character was the eccentric Erasmus Darwin. He was a fan of the work of James Hutton and often infused his own writings with the implication of a very old Earth, an impressive feat given the time period he lived. In his seminal piece, Zoonomia, he would make a very bold claim indeed. In the great length of time since the Earth began to exist, perhaps millions of ages before the commencement of all the history of mankind, would it be too bold to imagine that all warm-blooded animals have arisen from one living filament? I don't fully understand why Erasmus wasn't absolutely crucified for this, as later proponents of the transmutation of species would be. The best I can figure is that he sort of dwelled in the safe harbor of speculation. It's one thing to sort of throw something out there, and it's another entirely to pitch it as fact. We saw something similar with Galileo, who proposed his heliocentricity concept as a model with a mechanism. Even Erasmus's posthumous work, The Temple of Nature, which, side note, had to be edited by his great-granddaughter because 16% of it was too salacious.
I'm not judging you, but I'm just saying everybody else is gonna.
Opted to point only to the vague laws of nature. This saved him from the wrath of the scientific community and the church alike. Lamarck was bolder, taking his ship from the harbor and sailing it directly into a cyclone. His was not just an idea. Lamarck had a mechanism. To explain the range of complexity in organisms and their adaptations to a given environment, he proposed the complexifying and adaptive forces. Perhaps intuitively, the former explained why organisms are complex and some simple, from jellyfish to horses, while the latter explained how organisms adapted to a given environment. The adaptive force additionally changed organism characteristics through the law of use and disuse and the law of inheritance of acquired characteristics. Put simply, traits can be amplified or lost depending on how an organism uses it, and that individual organism's use or disuse is passed on to their offspring. This is typically illustrated using a giraffe's neck. Giraffes used to have short necks, but individual giraffes stretched their necks to reach higher foliage, slightly growing them across their lifetime. They passed these slightly longer necks onto their offspring, and over time, giraffes got longer necks. Lamarck outlined these ideas in Philosophie zoologique in 1809 to mixed reviews. Scientific criticism mostly revolved around the fact that there was simply no evidence for any of this. Strong people didn't necessarily give birth to strong offspring, and the fossil record didn't really exist at all yet as a means by which to see if Lamarck's processes were at play as time stretched into the past. It also trifled with that old plenitude of creation concept. If God created things very good in the beginning, why would species change? Why would they need to? You also have to remember that this was before much of the work by Anning and Cuvier and Buckland, etc. And it was starting to feel just a little bit dangerous because remember, people appreciated that humans were really similar to apes, that we were within the same group, but that was the result of common design, so it wasn't really a threat. But if species could change, well, Charles Lyell said this to his friend Gideon Mantell. If pushed as far as it must go, Lamarck's argument would prove that men may have come from orangutans.
Alright, dude. What the flip?
George Cuvier hated Lamarck's idea and rhetorically demolished him in the public sphere to the extent that Jean-Baptiste Lamarck died blind and penniless, the laughingstock of the scientific community. Truly, Cuvier's hatred was so potent that he shit-talked his fellow Frenchmen in the eulogy that he read at his funeral. Michael Taylor notes, addressing the French Academy of Sciences, Cuvier placed Lamarck in the rank of men who had been less severe in scrutinizing the evidence, who had mingled fanciful conceptions with real discoveries, and who, believing themselves able to outstrip both experience and calculation, had constructed vast edifices on imaginary foundations resembling the enchanted palaces of our old romances. Taylor goes on to quote a historian who argued that the eulogy was one of the most depreciatory and chillingly partisan biographies ever printed.
I was rude, but I was rude to an idiot.
Haters today could never. Michael Taylor notes in Impossible Monsters that Jean-Baptiste Lamarck was so poor he couldn't even afford to stay buried. His grave was rented, and when the lease was up, they exhumed him and threw his body into a lime pit. Geoffroy St. Hilaire, a colleague of both Lamarck and Cuvier, had his own model for the transmutation of species that got him boxing the latter as well. Cuvier would win this academic fight too, basically forcing St. Hilaire into early retirement and waving the fixity of species banner from the highest mountaintop. Taylor summarizes the impact. In England, the effect of Cuvier's victory was so profound that Charles Lyell, who had once been sympathetic to Lamarckian ideas, made sure that the second volume of the Principles of Geology contained an explicit censure of transmutation. In the immediate aftermath of this debate, the idea that species could adapt to their environment appeared as a dead letter. But the fixity of species had strong roots due to its connections with a much older argument. This argument was initially made by Cicero hundreds, if not thousands of years beforehand, but then brought to the modern age by Anglican clergyman William Paley, who published on it in 1802, Natural Theology, which is where the famous watchmaker argument comes from. In crossing a heath, suppose I pitched my foot against a stone, and were asked how the stone came to be there. I might possibly answer that, for anything I knew to the contrary, it had lain there forever, nor would it perhaps be very easy to show the absurdity of this answer. But suppose I found a watch upon the ground, and it should be inquired how that watch happened to be there in that place. I should hardly think of the answer I had given before, that for anything I knew, the watch might have always been there. There must have existed at some time, at some place or another, an artificer or artificers who formed the watch, for the purpose which we find it actually to answer, who comprehended its construction and designed its use. Every indication of contrivance, every manifestation of design which existed in the watch exists in the works of nature, with the difference on the side of nature being greater or more, and that in a degree which exceeds all computation. Watches are complicated. If you found one in nature, you would think that someone designed it. Watches are complicated, carefully crafted, and they perform a very explicit purpose. They tell the time. Nature is even more complicated than a simple pocket watch. Therefore, if pocket watches were designed and require, in fact, a designer, nature does as well. You can see how this would help a concept like species fixity. A designer might change the design of a given watch model, but it requires their hand interfering and making the changes. Pocket watches don't just change on their own. The year is 1831. William Buckland and George Cuvier continue their work in support of catastrophism, although the former will soon abandon the idea and the latter has less than a year left to live. Jean-Baptiste Lamarck has been dead for nearly half a decade, and Geoffroy St. Hilaire has bowed out of the debate with Cuvier. Mary Anning is quietly collecting her fossils, but the majority of her major discoveries are behind her, and although she doesn't know it yet, cancer burns in her chest. Charles Lyell has just published the first edition of his groundbreaking book, Principles of Geology, and a legion of the next generation of young naturalists stand ready to pick up the torch. As the decade kicks off, the scientific community knows that the antiquity of the Earth now stretches deep into the past, the heavens similarly sprawling out above into a universe of unknown size and age. As for the creatures of the Earth, they are remarkably complex and well designed for their environment, created by a watchful God in successive waves across the vast eons of history, the days of Genesis, or the immense primordial period before. The rocks beneath their feet groan and hiss over countless centuries at the mercy of geologic processes which slowly subjugate them into forming towering mountains and deep valleys. The environment shifts over these near infinite ages, wiping out ecosystems and requiring the intermittent hand of God himself to keep the Earth populated with species, helpless in the face of change. Yes, the year is 1831, and a man boards a boat. Charles Darwin was born in 1809 to a wealthy family in Shropshire, England. He was always interested in the natural world, but he struggled with early education. He found classes boring and opted instead to join his older brother in medical school at age 16. The school at Edinburgh was a medical school far enough removed from the influence of Buckland and Cuvier that it allowed for the discussion of Lamarckian ideas. The Plinian Society, a club Darwin joined, was a place for debate, and all ideas were welcome, even materialistic ones. Darwin had been aiding zoologist Robert Grant in his work on invertebrates and balked when Grant entertained the Lamarckian idea that species could change over time. Darwin was wary, but he knew about this as an idea. The idea that species might transmute over time had been softly pitched by his own grandfather Erasmus, and Darwin had read all of Erasmus's notes. These ideas were exciting and even a little bit dangerous, but Darwin was predisposed towards entertaining them due to his grandfather's work, and so the Plinian Society remained a safe place for discussions that maybe species weren't quite as static as people thought that they were. Still, Darwin was squeamish when it came to blood, and the harsh winters in Edinburgh were too much for him to bear. He dropped out in 1827, leaving him to haunt his father's estate. This would not do. He needed to be working on something, so Darwin's father sent him off to Christ's College at Cambridge to get an ordinary degree, after which he was to become an Anglican parson. Darwin would acquiesce, but would spend most of his time learning about the natural world. The story goes that on one of young Darwin's beetle collecting expeditions, he spotted a rare specimen, but his hands were already full of other beetles, so he just crammed beetles into his mouth so he could free up a hand to capture the new one, and then the beetles that were in his jaws started freaking out and releasing defensive chemical sprays, an experience which Darwin allegedly found disgusting yet fascinating. He also found himself reading books on the natural world generally, the first being William Paley's Natural Theology, which Darwin found to be a convincing argument for the fixity of species. The second was effectively an adventure log, Alexander von Humboldt's wild journey across the so-called New World. A love of the natural world, an open mind to hypotheses regarding it, and a thirst for adventure would predispose Darwin to take a job as a gentleman naturalist on the HMS Beagle for an expedition around the world. The captain of the HMS Beagle, Robert Fitzroy, needed someone to talk to. Allegedly, the previous captain of the Beagle had shot himself out of loneliness, because it's not like the captain could talk to the crew. That would be uncouth. So the idea was Darwin would act as a gentleman naturalist. The goal of the HMS Beagle officially was to chart coastlines. Darwin's job would be to survey the biological and geological phenomena and features that the ship saw and encountered along the way. The journey was supposed to take 2 years, and it took 5. So I suppose, unbeknownst to everyone, a pretty grand adventure was about to unfold. In December of 1831, at the tender age of 22, Charles Darwin stepped aboard the HMS Beagle. He could always become a parson when he returned, and this was a great opportunity to contribute to the scientific community. Fitzroy seemed nice as well. He had even given Darwin a gift to commemorate the beginning of their journey, a new book by some upstart geologist named Charles Lyell called Principles of Geology. The expedition took them along the west coast of Africa first. During days at sea, Darwin pulled up samples of water and marveled at the beauty of microscopic plankton. Many of these creatures, so low in the scale of nature, are most exquisite in their forms and rich colors. It creates a feeling of wonder that so much beauty should be apparently created for such little purpose.
And this epiphany was only the beginning.
At the small islands of Cape Verde, Darwin described ancient limestone formations which looked identical to the sand beneath his feet, and further made comparisons to the Temple of Serapis and the homes on the island, directly praising the genius of Lyell in his journals. In South America, Darwin took long journeys to shore and inland as the ship marked the coastline. Vast collections of organisms accumulated and were periodically sent back to England to make room for more. Darwin and the crew got along well, and they often aided him in his collection efforts. Fitzroy was more temperamental, once banning Darwin from his company when the latter expressed disgust at the slavery on display in Brazil. In Argentina, following the rumor a local farmer had discovered giant's bones, Darwin came upon the skull of what would later become known as Toxodon. Some local kids had leaned it up against a post and were throwing rocks at it when Darwin purchased it for 18 pence. He thought it resembled a rhinoceros, but was frustrated at the strange features that were a perfect fit to no living mammal. Decades after Darwin's death, Toxodon would be shown to be a part of an order of mammals that was entirely extinct. In Tierra del Fuego, Darwin met indigenous people whose customs and perceived savage behavior shocked him. He had been in the company of 3 Fuegians for some time who were now returning to their people as missionaries, and Darwin was shocked that these civilized men could be of the same stock as the still indigenous living Fuegians. These observations would influence a later book Darwin wrote on humans, supporting both the single species all living humans occupied and the prospect of more civilized behavior coming from more savage behavior. At Punta Alta, Patagonia, he found extinct mammal fossils, some like those described by Cuvier. The conglomerate rocks showed signs of slow tidal deposition rather than that of catastrophic events, yet again supporting Lyell over Cuvier. In Concepcion, Chile, Darwin and company experienced an earthquake that caused mass devastation and razed geological structures in mere hours. Small local catastrophes could be combined with mundane processes and cause large-scale geologic change over vast amounts of time and space. There was no need for a global flood or any other such events. Darwin would collect countless specimens, extant and extinct, travel up the Rio Negro and through the Andes, and document observations on animals, plants, and geologic phenomena. They had traveled the length of the continent on both sides. As the Beagle banked away from South America, small islands shimmered on the horizon, which would set the stage for Darwin's most monumental discovery. The Galapagos exposed the crew of the Beagle to colossal tortoises, antediluvian iguanas, and countless birds. Darwin noticed that many of the animals differed from island to island, and in the case of the mockingbirds he had collected, they bore a striking similarity to a mainland variety. These birds, which so closely are allied to the Thenica of Chile, is singular from existing as varieties or distinct species in different islands. I have 4 specimens from as many islands. These will be found to be 2 or 3 varieties, and each variety is constant in its own island. In addition to the mockingbirds, he would collect blackbirds, finches, and gore's beaks, although these birds were hardly discussed in his notes at the time. Darwin observed recently extinct volcanoes coughing up smoke and small glittering pools of brackish water, which attracted innumerable varieties of birds, and all the while he considered Lyell's rejection of the transmutation of species. It will be very interesting to find from future comparison to what district or center of creation the organized beings of this archipelago must be attached. These collections would revolutionize biology, but not yet. The Beagle sailed to Tahiti from the Galapagos, where Darwin was shocked by the civility of the indigenous population. He attributed their polite nature to the influence of Christianity on the island, and was pleased to see that the allegations he had heard of tyrannical missionaries exterminating local culture were evidently overblown. In Australia, Darwin met Aboriginal people, paying them for a spear-throwing demonstration and writing sadly about their decreasing numbers. He had also observed the strictly marsupial mammalian fauna of the continent and marveled at how for every placental mammal occupying a role abroad, there was seemingly a marsupial occupying that same role there in Australia. He remarked that an unbeliever might exclaim, "Surely 2 distinct creators must have been at work. Their object, however, has been the same, and certainly the end in each case is complete." I am always floored at just how casually Charles Darwin is discovering foundational concepts in science. He just described homoplazy there. At the Keeling Islands, Darwin gathered support for his own hypothesis on coral atoll formation, one which differed from Lyell's, and in South Africa he met the famed astronomer John Herschel. Herschel had also been a huge fan of Lyell's work, finding uniformitarianism to be a more compelling idea than catastrophism followed by sequential creation events. He deemed Cuvier's idea an inadequate conception of the creator. Like Darwin, he thought that species could change, and that the origination of fresh species, could it ever come under our cognizance, would be found to be a natural one, in contradistinction to miraculous processes. South Africa also exposed Darwin and Fitzroy to abusive missionary missionary practices, leading the latter to write a letter to the South African Christian recorder urging them to be more like Tahiti. At the remote island of St. Helena, Darwin had the time to review his notes on the mockingbirds of the Galapagos. These birds are closely allied in appearance to the Thenica of Chile or the Calandra of La Plata. In each island, each kind is exclusively found. Habitats of all are indistinguishable. These birds, but slightly differing in structure and filling the same place in nature, I must suspect are only varieties. The only fact of a similar kind of which I am aware is the constant asserted difference between the wolf-like fox of East and West Falkland Islands. If there is the slightest foundation for these remarks, the zoology of the archipelagos will be well worth examining, for such facts would undermine the stability of species. Darwin is suggesting that these species might actually be related, meaning they share a common ancestor, meaning species can change over time, and in fact, new species can form. Famously, that word would is inserted later on. This would undermine the stability of species, just underscoring how insecure he is about this idea that species might transmute over time after all. The HMS Beagle would traverse the Atlantic one more time to double check some readings, can you imagine, before arriving back home in London in October 1836. Darwin's voyage had exposed him to thousands of species, geologic structures of all sorts, and people groups from around the world. He experienced natural disasters, found enormous fossils, and made key observations that would change the face of geology decades later. While he had been gone, Cuvier had died and Lyell's uniformitarianism had taken over. The Bridgewater treatises had come out and basically argued the Earth was old, but God was cool with it, and the only holdouts were those scriptural geologists who didn't really have a background in geology. They were arguing mostly from a layman perspective. Also during that time, Louis Agassiz, a prominent Harvard naturalist, argued that there was a correspondence between the fossil record known at the time and embryonic development, and he thought that this was excellent support that successive creation events had occurred over time. He was a big Cuvier fan, that Agassiz. William Whewell coined the term science while Darwin was abroad, and economist and demographer Thomas Malthus passed away. Well now, he's not a naturalist. I wonder what he's doing here. Malthus had been the author of an essay on the principle of population, an argument and simple warning. The global human population was growing, and there are only so many resources. If humanity wasn't careful, the population would outpace the resource availability, leading to inevitable extermination, sickly seasons, epidemics, pestilence, and plague. If there are too many people and not enough resources, a global struggle for existence will ensue, as happened all the time locally during times of scarcity. The essay would be well received, and a copy of the 6th edition would fall into Darwin's lap in the year 1838, a tome which he would read for amusement. Put a pin in that. Darwin set to work immediately upon his return home, and he actually had a meeting within the first month with who other than Charles Lyell. They discussed some of Darwin's geological observations, which Darwin would then publish with Lyell's blessing. They would become friends and stay friends until Lyell's death many decades later. This spurred Darwin's rise in popularity as a naturalist, and soon he was rubbing elbows with many up-and-comers all across London, from Richard Owen to Charles Babbage. Richard Owen was just a few years older than Darwin, and he was a brilliant anatomist, as well as a ghost experience survivor. Michael Taylor documents 2 times Owen recounted seeing a spindly figure with narrowed, glimmering eyes in Lancaster Castle, a place Owen was fond of grave robbing from. Don't worry, it was for science, so it's fine. Once, after sawing the head off a former slave's corpse, he slipped on a patch of ice, dropping the head, which allegedly bounced down the hill and crashed through the door of a slave ship owner's wife.
Hey yo, what the fuck?
Owen was a museum dweller, spending copious amounts of time with specimens in various museums. This likely amplified his wide expertise in anatomy, an expertise which often required him bringing home rotting animals for dissection, much to the chagrin of his wife Caroline, who was often involved in his work. Owen was brilliant but stubborn, sharp-tongued, and quick to make enemies. His Wikipedia page has an entire section dedicated to conflict with his peers that begins with, Owen has been described by some as a malicious, dishonest, and hateful individual. He was known in the scientific community of the day to railroad the publications of his enemies.
It was very productive. I stopped several cases of confrontation, violence, destruction. Where was it coming from? From me, for sure.
Rigidly orthodox in his faith, Richard Owen, along with William Buckland, would systematically lambast those who were advocating for the transmutation of species, which meant that whispers of Darwin's work would set Richard Owen up as an enemy for life. Remember, William Buckland had been responsible for naming the very first dinosaur around a decade before Darwin's return from the voyage of the Beagle. He had received bones, including an enormous partial jaw discovered by John Kidd out of the Stonesfield Quarry in Oxfordshire that clearly belonged to some enormous reptile. Megalosaurus was a land-dwelling counterpart to Cuvier and Anning's monstrous marine reptiles, officially named by Buckland in 1824. Gideon Mantell would discover and name Iguanodon, although Owen would credit himself and Cuvier in 1825, followed by Hylaeosaurus in 1832. Owen and Buckland would eventually marshal these animals to fight against the growing support for species change over time. Meanwhile, around this same time, Darwin received word from ornithologist John Gould, the man who he had sent all those collected birds from the Galapagos to, and the news was very surprising. The Galapagos collection of birds was not a mixture of several known varieties, such as blackbirds, grosbeaks, and mockingbirds. They were all finches, 12 distinct species, and all bearing similarity to the more generic mainland bird, which was also a finch. Darwin was stunlocked. It is very remarkable that a nearly perfect gradation of structure in this one group can be traced in the form of the beak, from one exceeding in dimensions that of the largest grosbeak to another differing but little from that of a warbler. Darwin's mind was already racing, gingerly pulling together all the small and tentative observations from his journey. His red notebook, dated to just a few weeks after this revelation, has a cautious scrawling that would change everything. A diminutive family tree, not of individuals, but of species. It is labeled with the most sacred scientific phrase, I think. If species were like family trees, changing over time and converging backwards through the annals of history upon common ancestors, now a single enormous question hung over Darwin's head like a biological sword of Damocles. How far back did this go? The implications were unorthodox, thrilling, dreadful, and very, very dangerous. So Darwin did what anyone would do. He waited. He did publish a revised edition of The Voyage of the Beagle, adding a few cautious musings on finch variation. Seeing this gradation and diversity of structure in one small, intimately related group of birds, one might really fancy that from an original paucity of birds in this archipelago, one species had been taken and modified for different ends. Darwin lived his life for a lot of years. He got married after writing a freakish pros and cons list. He wrote books on geology and coral atolls and pigeon breeding and barnacles. He had children. He lost children, all while he mulled and puzzled and considered this strange, dangerous idea. Darwin read everything on species that he could get his hands on. He read the works of species fixity advocates. He read the books by people who thought maybe species could change over time. And included in this list was one strange piece by a one Thomas Malthus about population collapse. This idea that in a world with too many individuals and not enough resources to go around, well, that had pretty enormous implications if applied to the natural world, didn't it? That was the linchpin concept that pulled all Darwin's observations together. It's hard not to see some epiphany. The observations which would underpin his seminal work can be laid out like so. 1. Darwin considered the infinite population potential of all organisms and how it was constrained by the resource availability, leading to a struggle for existence. 2. Darwin had observed that populations were stable, despite the propensity of countless organisms to produce far more offspring than could survive to adulthood. 3. Darwin observed extreme variation, which was obvious amongst the offspring of all sexually reproducing organisms, and this variation made some offspring better at acquiring resources than others in any given environment. 4. Darwin saw that variation was evidently heritable. Successful organisms with beneficial characteristics grew larger, reproduced more, and passed those beneficial traits on. This led to organisms with certain characteristics becoming prolific within their populations, eventually leading to the elimination of all other varieties. Populations would stay this way as long as the environment continued to advantage those traits. However, 5. Darwin noted the environment was always changing, sometimes slow, sometimes fast, but it was always in flux. In other words, populations are constrained by resource availability, meaning individuals have to compete for what is available. Some individuals are better at acquiring those resources than others are, and the ones who are better at it get bigger and produce more offspring, which inherit those characteristics that made their parents better at acquiring resources. Over time, those characteristics will come to define that population, and the population as a whole will be better adapted for the environment in which it lives. But the environment is always subject to change, and what is ideal in one environment isn't necessarily ideal in another. If the environment changes so as to advantage new characteristics, those new characteristics will be favored as compared to the older ones, and the population will change over time. Again, and so populations will always change over time as individuals are filtered out by the environment in which they live, and individuals well suited for it proliferate more. Organisms thus were extremely well suited for their environments, but not because they were designed for it, they were designed by it. This was the transmutation of species, but with a mechanism, natural selection, which seemed to work. Darwin pitched his idea to several of his esteemed colleagues, and frankly, he was a histrionic diva about the entire thing the whole time. He first sent his ideas to his friend Joseph Hooker, a botanist who had done his own extensive voyage to the southern hemisphere on the HMS Erebus before it was creepy and mysterious. Darwin felt like his idea was akin to confessing a murder. Hooker thought he made important points, but thought perhaps successive creation may also be involved. Lyell, too, was hesitant. No one had more respect for Lyell than Darwin. He once remarked on Lyell's genius with regard to geology, seeing a thing never seen by Lyell, one yet saw it partially through his eyes. If Bestie wasn't on board, that would make this whole thing a whole lot harder. So Darwin sat on this radical idea for 20 years. Others weren't so content to wait. In 1844, an extremely controversial book was published anonymously. It was called Vestiges of the Natural History of Creation. This book, which virtually everyone suspected was written by geologist Robert Chambers, brought a version of Lamarck's idea to England. Organisms transmuted through vast geologic time, progressing upward to higher and more complex forms thanks to the natural laws set forth by God, but not by God directly tinkering. It got some things right, but was objectively flawed. Darwin was among its enormous audience of readers, noting, "I must allude to this for when he would drum up his own species concept." In a lot of ways, this book was just British Lamarckism. It did propose a mechanism, unlike zoonomia, and it was a bestseller, but the most important thing that Vestiges did is it got people talking about the transmutation of species again. Richard Owen was not happy. He turned back to those terrible lizards with his ally William Buckland. They had a plan. They pitched these giant ancient reptiles as the pinnacle of creation, amazing organisms that were truly kind of peak physical perfection, so how could an environment ever be non-hospitable to them? And if organisms continued to rise in complexity over time, why had these creatures, which were about as majestic and complex as something could get, go extinct? Owen dubbed this group of creatures the dinosaurs in 1841, and, as previously mentioned, marshaled them as support for the fixity of species as opposed to the transmutation of species. Another young naturalist, unconvinced by the folly of the transmutation of species, was Thomas Henry Huxley. Huxley was born in 1825, belonging to the generation of naturalists following the likes of Darwin and Owen. He was a self-made man and autodidact, reading everything he could find on the natural world. Huxley would borrow money to attend medical school, a gambit which would pay off, but not in the way he might have thought. In order to pay off his debt, Huxley took on the role of an assistant surgeon in the Royal Navy, being stationed on the HMS Rattlesnake. The purpose of the voyage was to chart around New Guinea and Australia, with Huxley in charge of the gentleman naturalist collecting. He would meet Henrietta Heathorn in Sydney, and to use modern parlance, he was down bad. According to Michael Taylor, they were engaged after 5 meetings, not dates, meetings. Huxley wanted to move forward with the marriage to Henrietta, but for this he needed money and a stable gig back in London's academic world. Surprisingly, some support from the latter would come from Richard Owen. Owen was devoutly religious, to a fault in the eyes of the scientific community even at this time, and Huxley was a pretty pointed agnostic, fairly risky for that time, and he also palled around with a lot of other secular thinkers. But while they differed on religion, Huxley actually balked at the idea that a divine agent would have any role in the natural world. They did have one thing in common, and that's that they hated vestiges. Like Owen, Huxley found the concept of the transmutation of species to be laughable, and also like Owen, Huxley was a bit fighty. Despite being friends with Chambers, the supposed author of Vestiges, Huxley would call the text a waste of paper, musing, "Time was when brains were out, the man would die."
I don't feel like it's a representation of me, but I guess it is.
Huxley was actually giving a lecture on his problems with the transmutation of species in 1855 to the Royal Institution, with a nervous Darwin in attendance. Darwin was impressed by the young Huxley, whose devotion to scientific rigor and empiricism was plain to see, and he set about to change his mind. The two would become fast friends, but for now, Huxley remained unconvinced. Huxley needed to see Darwin actually lay out his case, but all the naturalists seemed to be doing right now was contemplating. He was procrastinating. Meanwhile, in an obscure quarry in the British territory of Gibraltar, a group of men found a very odd skull. They'd been collecting stone to reinforce a military installation when they happened across a face staring back from the rock. They presented the find to the Gibraltar Scientific Society, where it was promptly put into storage with the label, "An ancient human died before the universal flood." This cranium would rest in obscurity for over a decade. Abroad in the United States, unrest raged, or to use modern parlance, shit was hitting the fan. The abolitionist movement began in the 1830s as citizens of the young nation demanded immediate emancipation. Politicians were more hesitant. Slavery needed to end, sure, but immediate abolition was extreme. Liberal Northerners, free black citizens, and Protestant evangelicals like the Quakers were not content to wait. But Christianity, as the dominant religion of the United States, had players on both sides of the chessboard. In the South, Christians in favor of slavery formed the Southern Baptist Convention, and those who argued for white supremacy did so with the support of some Northern naturalists. Now prominent naturalist Louis Agassiz argued, quote, "The brain of the is that of the imperfect brain of a 7 months infant in the womb of a white," unquote. Although Agassiz never openly in writing supported slavery, these arguments were not made in a vacuum. In 1850, he formally argued that God had created all races separately and that those racial differences were akin to the subspecies or even the species level. And Agassiz was not the only one to weaponize the Christian creation story. French aristocrat Arthur de Gobineau would argue that the Aryan race was the original perfect human form, with the other races belonging to separate creation events. It is, of course, naive to suppose that ideas like this didn't reach American Southerners, who were hungry for some kind of theological reason to justify the subjugation of their fellow man for profit. Things would not reach a head in the United States until the 1860s, but the rising tensions surrounding slavery and the pervasive racial prejudice of the Western world influenced the reception of science to come, particularly when it would come to argue against the divine supremacy of some races over others. This was not isolated to the United States, of course. Darwin and Huxley were both outspoken abolitionists and clashed with many of their peers for condemning slavery in all its forms. Elsewhere, science continued to advance in little ways. In the year 1854, at a quiet monastery in what is now the Czech Republic, an Augustinian monk named Gregor Mendel began breeding pea plants. In just a few years' time, he will discover genetics. Another major discovery, which would not be appreciated in its time, occurred in 1856 when a small group of German workers attempting to clear a cave where the German Dussel met the Rhine pulled a very strange partial skeleton of an odd-looking human from the muck and mire. The men sent the remains to a nearby anatomist at Bonn, Hermann Schaefhausen, who wrote up the find. The skull cap of this individual was thick-walled and sloped, scarred by powerful muscles, and the brow ridge shocked him. It gave the cranium a look like that of the large apes. This individual clearly belonged to some barbarous race of men that lived long ago. The true nature of this discovery would have to wait a while yet. In 1858, Charles Lyell received an early manuscript from some young scientist titled On the Law Which Has Regulated the Introduction of New Species. Lyell couldn't believe his eyes. This was basically Darwin's entire idea. So being the ride-or-die best friend that he was, he reached out to Chucky D and was like, listen, you need to publish ASAP, or you need to reach out to this scientist, whoever he is, and orchestrate some kind of collab. Alfred Russel Wallace was born in 1823, and unlike many other gentleman naturalists, in fact it's almost a prerequisite, he did not come from an exceedingly wealthy family. This is to the degree that we aren't even 100% sure as to his nationality. Wallace worked several different jobs in his early life, land surveying and the like, but he was always most interested in the natural world. Wallace also seemed to have very bad luck. He lost his father and a brother in the early 1840s and faced trouble keeping businesses afloat. Using his spare time, he collected insects with entomologist Henry Bates, and the two frequently discussed the latest advancements in the natural sciences. They read Malthus's essays, they read Vestiges, they read Darwin's memoirs, and those by William Henry Edwards, and came to the conclusion that a journey abroad may be both scientifically rewarding and financially lucrative. Evidently, collections could go for a lot of money back then. The plan? Collect duplicates of as much as possible and sell them to private collections and the British Museum. Brilliant! There's really only one thing that could mess it up. Anyways, they set off on the HMS Mischief in 1848, bound for Central and South America. Wallace would spend 4 years charting the Rio Negro and collecting specimens, while Bates would stay for 10.
In 1852, Wallace's ship was packed to the gills with plants and animals.
Along with his precious notes and musings, he had spent the first few weeks of travel feverish and sick, but he was on the mend when the captain reportedly entered his quarters and said, "I'm afraid the ship is on fire." Evidently, a collection of resins had spontaneously combusted, leaving the HMS Helen coughing black smoke as it consumed Wallace's collections and eventually the ship itself. Wallace and the crew would be set adrift in the open ocean on a small lifeboat, not knowing their fate. 10 days later, the Jordison, an ancient and plodding boat headed to the UK from Cuba, would come to their aid. The ship that rescued them didn't even have enough food, so they had to be on strict rations for weeks. I'm just trying to imagine this. Can you put yourself in Wallace's shoes here? You're sitting on a lifeboat, it's been 9 days, and all you have to think about is how thirsty and hungry you are, how hot you are, and how you just lost absolutely everything in a boat fire. Then you get picked up by this random boat that doesn't have enough food for everybody, so you're on rations for the next several weeks, and also the entire crew that rescued you is pissed off because it's your fault that they're on rations. And of course, you're still mulling over the fact that your life's work is at the bottom of the ocean and also ash. What a nightmare. Luckily, Wallace was at least aware that he had horrible luck or had accidentally been cursed by some kind of forest witch because he had the entire collection insured. Wallace lived on the meager payout for 1.5 years, publishing on the notes and specimens that had survived. He also met many up-and-coming naturalists such as Thomas Huxley, and very briefly he chatted with Darwin himself, a veritable science celebrity now. Astonishingly, Wallace wanted to get back out there. He had unfinished business. Now, he wasn't willing to go back to South America, understandably, I think. He opted instead to do an expedition in the Malay archipelago. Funding was provided by none other than Lyell and Anning's old pal Murchison, letting Wallace set off in 1854. Alfred Russel Wallace would collect over 125,000 specimens over the next 8 years, sending a lot of them back as he collected them this time. Lizard species bearing stunted legs allowed him to muse on the nature of rudimentary structures. Orangutans haunted the trees above, their expressions and mannerisms disturbingly man-like. Thousands of beetles, wasps, butterflies, and ants were perfectly suited for each of their roles in the environment around him. The local jungle fowl was so reminiscent of modern domesticated chickens that Wallace thought perhaps it may be their ancestor and sent one to Darwin for his consideration. An odd, invisible geologic line seemed to cut through the land, separating a placental ecosystem from a marsupial one. Wallace's brain churned with ideas and connections, but it would not be until 1858 that it came together for him. In the clouded jungles of Borneo, amidst the burning orange of tigers and orangutans, and in the shadow of crumbling Hindu temple complexes, Wallace was stricken with a terrible illness. According to records, it was in fitful delirium that he, just like Darwin, recalled the essays of Malthus. In a world of limited resources and countless challenges, in a world where organisms varied from one another and competed for those few resources in hostile landscapes, some would be better fit for the job than others. The struggle for existence demanded that only the fittest organisms within their populations could survive, and each new and natural variant that emerged would be tested against its brethren. If it was more successful with these new traits, it would grow large, reproduce often, and pass those traits on. This would recapitulate with the offspring and their offspring, and so on until the entire population, even the entire species, was shaped into the likeness of the new beneficial trait. The transmutation of species. Wallace would recover, obviously, and immediately send his manuscript off to the biggest name currently considering whether species could change or not, and that was Charles Darwin. And so, On the Law which has regulated the introduction of new species came into the hands of Lyell and Darwin in 1858. Two men independently reaching the same conclusion under similar observation, it was time to publish. Darwin sheepishly asked Wallace if he might consider collaborating, which thrilled Wallace to the extent that he evidently bragged to his mom about it. To establish priority, Darwin presented a small summary of the general theory at the Linnaean Society that year, but without a full outline, including active observations and examples, the presentation impressed few. One fellow present remarked that all that was new in them was false and all that was true was old, a scathing line that evidently pissed Darwin off for years. Darwin and Wallace's idea needed a robust pitch before it was to be given a hearing in the scientific community. It needed to be argued. At last, Darwin set to work on his big book, a tome that would outline the argument formally. This notion thrilled Lyell. He was actually so excited by the prospect that he reached out to the same publisher, John Murray III, who had helped Lyell get Principles of Geology out there 3 decades earlier. Now, Lyell himself wasn't actually fully convinced of Darwin's argument. He wasn't fully on board with the idea that species could change, but ride or die as he was, he wanted to give his friend a shot to make his case. 1 year after the soft launch to the Linnaean Society on the origin of species and variation by means of natural selection was published. It was one long argument, a case made for the idea that species could change over time. 500 pages outlined the principles of natural selection by grounding them in common sense applications to domestic animals and his own observations on the voyage of the Beagle. Populations of organisms changed because they struggled, competing against one another and having differential reproductive success depending on their characteristics. How far back did this change go? All the way to the very beginning. There was a tree of life that connected all living things to one another and countless ancestors stretching through the mists of time and space to a common ancestor of everything. Darwin's allies had seen the publication first, and it instantly won over Huxley, who was so fully convinced by Darwin's case he would be the idea's most vociferous supporter. Lyell was deeply conflicted, for this common ancestor proposed by Darwin wasn't just the forebearer of everything, but also the predecessor of everyone. Humans weren't just animals, but animals at the mercy of the same natural processes as everything else. In one of the only mentions of its application to humans in Origin, Darwin suggested that this new theory might throw light on the origin of man. If species changed over time due to natural selection and the human species was not excused, had humans always been humans, or had they come from something else, something more primitive? Did they share that common ancestor with all other life? Lyell balked at the idea on a theological basis, but was simultaneously stunned by the argument Darwin had made for the origin of species via natural selection. In letters to Darwin and Huxley, he couldn't help but muse about the nature of human change over time with relation to one of his favorite subjects, fossils. In a prediction that had, unbeknownst to him, already come to fruition, Lyell wrote to his friends, "We shall in time discover extinct fossil varieties of man." Origin's impact reached the other side of the pond as well, where it fell into the hands of renowned botanist and prolific Harvard professor Asa Gray. Gray was one of the founders of American academia as we know it, and a strong opponent to the other American scholar at play here, Louis Agassiz. Like Darwin, Gray abhorred slavery and argued all humans were of a single species. Gray was vocally Christian and felt that it taught under no uncertain terms that all humans were united biologically, a notion supported by the scientific fact that all humans could interbreed. Gray knew Darwin. He had met him in 1839 through their mutual friend Hooker while visiting London, leading to a lifetime of correspondence. Darwin and Gray would bond over their empirical approach to science and, together with Hooker, would collaborate over the years. Asa Gray was convinced of the transmutation of species before Hooker was, and certainly before Lyell was, due to his own work with plant hybridization as well as Darwin's musings in Voyage on the Galapagos finches. Origin was different though. Origin outlined the actual engine for species change, as well as the limitless bounds it occupied. Gray would receive his copy just before Christmas and found it to be a tour de force. He would be Darwin's strongest American advocate, organizing the book's sales and copyright and fiercely advocating for its veracity. He would also ardently oppose both scientific and theological arguments against Darwin in the States, insistent that natural selection was a wonderful mechanism designed and set forth by God. Darwin's long-form argument in Origin had also convinced earlier doubter and friend Joseph Hooker, who called the idea ingenious and original. Gray, Lyell, and Hooker represent wonderfully the microcosm of how religious men and women perceived origin in a broad sense. The idea was phenomenally pitched and well supported, but taken to its logical conclusion, the change in species due to natural selection could be theologically perilous. This dangerous idea, this brilliant process, this wonderful mechanism had a name beyond the transmutation of species, but it is uttered only once in the entirety of the first edition of On the Origin of Species as the very last word. There is grandeur in this view of life, with its several powers having been originally breathed by the Creator into a few forms or into one, and that, whilst this planet has gone on cycling according to the fixed laws of gravity, from so simple a beginning, endless forms, most beautiful and most wonderful, have been and are being evolved. Evolution, the change of species over time and convergence upon a last universal common ancestor, was an absolute smash hit at home and abroad. Despite the exclusion of the topic, the one thing on everyone's mind seemed to be the same question that itched at Lyell's brain. Did this apply to humans? The church had a wide range of responses. Older clergymen found the idea theologically untenable, arguing that the origin of man ought to be left to religion, not science. Younger clergymen found it to be an elegant means by which God designed. The heresy bonk was suggested, but it was shut down by the New Blood, which felt that this was no different from any of the other science that the church had come to accept and harmonize with their theology. Essays and Reviews was published in 1860 by 7 Anglican theologians and ministers with the goal of reconciling the advancements in science, history, and philosophy with Christianity. Frederick Temple was one author who had previously affirmed his support for evolution by comparing the clear truth of it to the shape, position, and age of the Earth. Christians need not be afraid of natural laws. This was echoed by Baden-Powell as well. The real trouble with Essays and Reviews came not from the science affirming, but from those beginning to push back on the historical accounts from the Bible, such as the Exodus. This came from the likes of Roland Williams and Henry Wilson, and their controversial opinions would get essays selling like hotcakes and at risk of a serious heresy smackdown. Among the scientific community, Richard Owen was the most prominent and scathing detractor of Darwin's ideas. Owen kind of liked Darwin. He appreciated the specimens that Darwin had donated to the museum years earlier, and in the spirit of that and politeness, he said that he would review Origin in full eventually, but instead he anonymously slammed the text. First, he called it an abuse of science, which was insulting enough already, but then he said that it reminded him of French science, which...
Today, I'm going to be day drinking and smoking cigarettes in a public park at 2 p.m.
He's lucky he didn't get challenged to a duel over that one. I would want my satisfaction personally. The weird thing was, Owen had kind of come around to the idea of the transmutation of species. Sort of. He just didn't think that it could occur in a naturalistic way. Owen conceived of God as a divine tinkerer working with created archetypes, and evidently humans as being separated from virtually everything else. Owen's archetype did not go over well with Huxley, who found it fundamentally opposed to the spirit of science. Like diluvialism before it, Owen's archetypes were untestable. They weren't really science, they were just a sort of gesture at science. But Owen wouldn't be the only one to leverage religion as a primary attack against evolution. Some of these detractors would be Darwin's colleagues and old teachers. William Whewell banned the book from Cambridge, despite being quoted numerous times in Origin. John Henslow called it a stumble in the right direction. Old Adam Sedgwick, his former professor who had been convinced by Lyell of the ancient uniformitarianism Earth, wrote to his former student, "I have read your book with more pain than pleasure." Like many critics, his concern came not from the science, but from the implications of it. Humanity would suffer a damage that might brutalize it. Darwin's supporters were swift to respond. In the UK, Joseph Hooker would write directly on his support for evolution in his botanical texts, released just 1 month later. In the United States, Asa Gray would sing Origin's praises, taking care to let his audience know that this is not an atheistic text, as some were already trying to spin it. According to Gray, Darwin's views on variation were general and even universal, his argument fair and natural, and certainly not necessarily atheistic. And our other main US naturalist was unimpressed. Agassiz thought that Darwin's theory was a collection of mere guesses, one which was a scientific mistake, untrue in its facts, unscientific in its methods, and mischievous in its tendency. In the Westminster Review, Thomas Huxley praised On the Origin of Species as the most compendious statement of well-sifted facts bearing on the doctrine of species that has ever appeared. He denounced special creation as verbal hocus pocus that had been a mere specious mask for our ignorance. Huxley argued that Darwin's work does not so much prove that natural selection does occur, as much that it must occur. As a general summary, though, the praise primarily came from the scientific community, and the detractors came from a very particular conservative branch of the theological one. In 1860, Samuel Wilberforce, the Bishop of Oxford, levied a criticism against Origin at the British Association meeting where Huxley was in attendance. Darwin was sick, and Huxley was present at the behest of a friend and former punching bag, Chambers, the author of Vestiges. In front of a packed audience, Wilberforce praised Origin's prose before arguing that the evolution of species had never been observed. The mummified Egyptian animals and plants from thousands of years ago resembled those of today, and how could man be a descendant of something so low as a primate when his faculties were so ascendant? He then turned directly to Huxley, now a well-known ally of Darwin, and asked, "Was it through your grandfather or grandmother that you claimed to descend from a monkey?" The audience erupted in laughter and applause while Huxley, according to records, turned to the chemist seated beside him, named Benjamin Bodie, and whispered, "The Lord hath delivered him into my hands." Huxley stood, regarded the audience, and said loudly and proudly, "If the question is put to me, would I rather have a miserable ape for a grandfather, or a man highly endowed by nature and possessed of great means and influence, and yet who employs these faculties for the mere purpose of introducing ridicule into a grave scientific discussion, I unhesitatingly affirm my preference for the ape." The crowd went insane. Overseas, Asa Gray was fighting a similar battle as Huxley was, but unlike Huxley, Asa Gray was devoutly religious, and so he took a slightly different strategy. Gray published essays reconciling evolution by natural selection and religion with a straightforward piece titled Natural Selection Not Inconsistent with Natural Theology. It was extremely successful and provided a seamless road for religious folks of America to accept Darwin's ideas. Back in the UK, though, things theologically were reaching a fever pitch. The whole essays affair had Wilberforce and many others responding with their own essays within the same year, and led to an official heresy bonk of all 7 authors. They were eventually acquitted, but this just goes to underscore the deep, quivering anxiety that the British public felt when looking modern science, history, and philosophy in the face. Were these 3 fields actually trying to harmonize themselves with scripture? Or were they trying to run it out of town? These theological tensions were now evident to the public as well, a notion that greatly upset Charles Darwin. He and Asa Gray had been corresponding for years about the nature of his idea and its relationship to God, which Darwin felt was a subject too profound for the human intellect. A dog might as well speculate on the mind of Newton. He arranged to have Gray's pamphlet redistributed in London in 1861 in hopes of assuaging people that, as he had remarked to Gray in a letter, evolution by means of natural selection was not at all necessarily anti-theistical. After all, within the scientific community, the vast majority of scientists were Christians, were religious, including Hooker, Lyell, Gray, and when he published On the Origin of Species, Darwin himself. The pitting of religion against science was already wrong in their eyes philosophically, but worse yet, it made them uneasy. Was their work next? Despite this, the support for Darwin's evolutionary theory continued to grow, much to the chagrin of Richard Owen. Owen hated the idea of species transmutation, of course, but he hated the idea that humans are evolved primates even more. Worse yet, humans being closely allied with other apes in a physical sense had been cemented since Linnaeus and confirmed by his own extensive anatomical studies. Owen needed a defining difference to set humanity apart, and for this he turned to the brain. The hippocampus minor was the defining feature. Only humans had it, he argued, and it endowed them with their special mental faculties. As it happened, Owen was also at the 1860 British Association meeting, and in addition to cementing Huxley as Darwin's bulldog, that meeting would also spur one of the greatest debates of the next few years when Owen took the stage and claimed he would be bringing forth facts which put Darwin's theory to the test. He outlined his hippocampus minor argument, claiming that the brain of the gorilla was more different from that of a man than from the lowest primate, particularly because only man had the posterior lobe, a posterior horn, and a hippocampus minor. This sent Darwin through the roof, as he famously remarked, "Man as distinct from a chimpanzee as an ape from a platypus. I cannot swallow that." And in fact, few could. This was a uniquely bizarre position, more extreme than the one that was outlined by careless Linnaeus, the father of taxonomy, a creationist who lived nearly 100 years prior. It was goofy. Huxley shrugged this argument off, insisting it held no support in existing science, but additionally promising he would prove Owen wrong personally. He was delayed by tragedy when one of his children fell sick with scarlet fever and died rather suddenly, but this loss seemed to fuel him more than ever. Huxley published a paper outlining Owen's previous work and asserting that Owen himself had expertly shown via his own anatomical descriptions that humans and other apes all had the same brain regions, differing only in size or emphasis, the same as Edward Tyson had done before him, also a trend found within humans. Owen hit back again, doubling down on his original claim and simultaneously publishing and holding a lecture on the subject, but the publication's accompanying illustrations were immediately clocked by Huxley as inaccurate, something Owen would blame the artist for before urging audiences to consider his previous work on the subject in 1858, where he had already made his case. Trying to challenge a criticism by reasserting the original argument. Where have I heard that one before? Huxley would reportedly respond to this by saying life's too short to occupy oneself with the slaying of the slain more than once, in effect saying he was done with the debate. The problem was, Huxley loved to debate creationists, so this grandstanding wouldn't last. Heh, couldn't be me. Owen would triple down yet again, this time launching a smear campaign against Huxley, spurring Huxley to publish zoologist George Rolliston's notes on the orangutan brain, clearly displaying the hippocampus minor and all other human brain features. Owen retorted that this was simply a matter of interpretation, the ape brains he had lacked this feature. Huxley reportedly said to Hooker, "Owen occupied an entirely untenable position. The fact is he made a prodigious blunder in commencing the attack, and now his only chance is to be silent and let people forget the exposure. I do not believe in the whole history of science there is any case of a man of reputation getting himself into such a contemptible position. He will be the laughingstock of all the continental anatomists." Then, shortly after Owen's most recent quadruple down, Huxley marched down to the zoo where a spider monkey had recently died and held a public dissection to make his case. Not only did the non-human apes have the hippocampus minor, but monkeys, and platyrrhines at that, did as well. Anatomist John Marshall joined the bandwagon and published his measurements of a chimpanzee brain, noting that preservation can shrink or diminish structures, perhaps explaining Owen's enormous mistake. Now the question was, would Owen correct his mistake? The debate would be immortalized in a children's book of all places. Charles Kingsley was a priest, professor, and a progressive who authored The Water Babies, a fairy tale for a land baby. A friend of Darwin who found origin convincing, this book tells the story of a young boy who transforms into a water baby. You don't need to know what that is. That simultaneously acts as a satire of scientists reticent to progress, a polemic against child labor and pollution, and a diss track against, according to Wikipedia, Americans, Jews, blacks, and Catholics, particularly the Irish. The Great Hippocampus question became the Great Hippopotamus question in the story, and Kingsley chides those who think that science is all figured out. You must not say that this cannot be, or that that is contrary to nature. You do not know what nature is, or what she can do, and nobody knows. Not even Sir Roderick Murchison, or Professor Owen, or Professor Sedgwick, or Professor Huxley, or Mr. Darwin, or Professor Faraday, or Mr. Grove. Time would tell for the Great Hippocampus question, but for now, Owen's attention was turned elsewhere. Some German quarries were turning up very odd fossils indeed. Jurassic rock was spitting out the unthinkable. Feathers. Feathers belonged to birds, modern animals who certainly did not live during the Mesozoic, and yet a quarry known for dinosaurs was coughing them out. Matters got odder when shortly afterwards a partial skeleton bearing the same feathers and missing its head was discovered by Karl Haberlein. The skeleton had a bony lizard-like tail that no bird had ever possessed. If this was a bird, it was a very odd one indeed, and if it wasn't, the implications were probably immediate to Owen, who set out to buy the specimen. 1 year before Darwin published Origin, American paleontologists William Folk and Joseph Leidy discovered something that would piss Richard Owen off. It was a new dinosaur, found after chasing a local legend in Haddonfield, New Jersey, and it looked a lot like Iguanodon. However, this dinosaur's forelimbs were so short, almost atrophied, suggesting it must have been able to walk bipedally in a semi-erect posture. That was exactly what Richard Owen had previously told Gideon Mantell Iguanodon couldn't do, which led to the beast's reconstruction at the Crystal Palace having a sprawling super lizard-like stance. This dinosaur, dubbed Hadrosaurus, could not be reconstructed in such a way and must have, at least some of the time, been a biped, as Mantell had suggested for Iguanodon. They rushed to write this up, but publication was delayed due to the outbreak of the American Civil War in 1861. More on that later. Meanwhile, back in the UK, Owen procured the odd-feathered specimen in 1862, and despite being scooped by an anonymous writer known as Y, Owen spoke on the strange fossil shortly after. To Owen, it was a very odd bird, but a bird all the same, one that probably couldn't even fly. Perhaps this was the creator's archetypal bird from which all modern birds descend? Owen no doubt hoped that no one would notice. Huxley was now an anatomist considered to rival Owen, and in 1863, without even having seen Owen's specimen, he had already connected the dots. Huxley taught his students that birds were so essentially similar to reptiles in all the most essential features of their organization that these animals may be said to be merely an extremely modified and aberrant reptilian type. It seems that Owen's preemptive lecture was warranted, because if this new fossil species, known now as Archaeopteryx, truly did have a mixture of bird and dinosaur features, that birds had actually evolved from dinosaurs. Owen had a bit of time though to get his bearings, because for now the attention had turned back to humans. World-renowned and enormously well-respected geologist Charles Lyell had been working on a new book. It was published in 1863, titled Geological Evidences of the Antiquity of Man, and it made a similar case as the Principles of Geology, but to the age of humans as denizens of the planet. He appealed this time to archaeology, pulling extensively from field sites all over the world, from the Americas to Egypt, and argued that human history was at least 7,000 years old. Here, Lyell also formally accepted Darwin's proposition that species could change, although much to Darwin's disappointment, he refrained from co-signing the evolution of humans among those species which had descended. Lyell responded to Darwin's exasperation, "I have spoken out to the utmost extent of my tether, so far as my reason goes, and farther than my imagination and sentiment can follow." But if Lyell had been contemplating, Huxley had been stewing. Darwin's Bulldog would be one of the first to publish on the topic Darwin had so feared reprisal for: human evolution. Evidence as to man's place in nature was released the same year as Lyell's Antiquity, as an argument akin to Origin, but specifically in relation to humans as apes which descended from other apes. It was chock full of comparative anatomy of humans and other primates, naturally with a focus on apes, and answered almost explicitly many of the open questions on human evolution Lyell had hinted at in Antiquity. Like Antiquity, Man's Place in Nature was a smash hit, leaving Huxley stunned at how little criticism he received. A copy even made its way to Frederick Engels, who sent it to his buddy Karl Marx. Yup, these guys all lived at the same time. Later that year, Irish anatomist William King examined those strange remains from the German valley and concurred with Schaffhausen. These were human-like, but they weren't human. King emphasized the brow ridge and several other more apish features and proposed that this was a different species of human entirely. Named after the valley its type specimen was discovered in, Homo neanderthalensis was christened. In 1864, another fossil that we'd technically already met would debut to British naturalists thanks to the release of Origin. Gibraltar I, the actual cranium of a Neanderthal, would get a formal presentation. George Busk had brought it back from Gibraltar and hoped it would settle an argument. Another Bonn anatomist, August Franz Joseph Karl Mayer, had diagnosed Neanderthal I as being a pathologic human, probably just a Russian from the time of Napoleon whose body had been altered due to the strain of the life of a soldier on horseback. The skeleton had healed, broken bones, something Mayer thought would have put the individual in immense pain, probably probably a constant grimace. That would explain that big brow ridge. A staunch creationist against species transmutation, Mayer proposed that this skeleton had once belonged to a Cossack who had, in the throes of pain and on the run, holed up in the Neander Valley cave to die. Buss hoped that the Gibraltar 1 cranium would put an end to Mayer's particular argument. It's not like he could say that a rickety Cossack from 1814 would have holed up in the clefts of the rocks at Gibraltar. It didn't make sense. But however excellent the Gibraltar cranium was, it wouldn't actually settle the debate. It lacked postcrania, so how could it even be compared to the Neanderthal 1 remains? No, the Germans felt that the debate wasn't quite settled, not just yet at least. Darwin wanted to attend the original debut of the specimen, but was, as was typical these days, hung up with sickness. Ever the bestie, Lyell would organize for the cranium to come to Darwin. He would write to Hooker, "Falconer brought me the most wonderful Gibraltar skull." This would not be all he would say on the hominin, but he had other fossils to take stock of. Darwin continued to publish revised editions of Origin as he worked on other projects, and Archaeopteryx had not escaped his notice. He included the strange creature in his 4th edition of Origin in 1866, noting its odd tail and similarities to reptiles. Meanwhile, Darwin's bulldog, luckily for Owen, was a bit preoccupied with his X-Club, as well as lambasting the Anthropological Society for its pro-racism stance on the Jamaican Revolution. Huxley wouldn't see the London Archaeopteryx specimen himself until the year 1867, and while Owen probably already knew how Huxley was going to interpret it, what Owen probably didn't anticipate is that other naturalists had beat Huxley to the punch on this one. In 1866, German anatomist Carl Gegenbauer and American paleontologist of the Wild West Edward Drinker Cope both published on the affinities and potential descendants of birds from dinosaurs. Cope would become one of the 2 main players in the big bone rush of the American West, where the soon-to-be states were becoming the next mega dinosaur hotspot. Cope would battle for paleontological supremacy with Othaniel Marsh as skeleton after skeleton, species after species emerged from the dust of the American Badlands in the 1870s. 1865 finally brought that old monk Mendel's discovery of genetics to the scientific community, where they were promptly ignored. Mendel had charted 7 general characteristics, such as seed color or flower location, for over 28,000 pea plants from 1856 to 1863. Mendel realized these traits were distinct and sorted independently from one another. Seed color seemed to be unrelated to flower location, for example. Some traits also seemed to persist and express more easily than others, leading Mendel to coin the terms dominant and recessive. These observations would become the laws of inheritance, the law of segregation, the law of independent assortment, and the law of dominance. But for the time being, the origin of genetics and one of the most hardcore, quantitatively exhaustive experiments as yet performed was met with basically nothing, was met with a whimper. It didn't help that in an attempt to replicate his own work, one of the hallmarks of good science and the scientific method, Mendel would inadvertently use an asexually reproducing plant called hawkweed, erroneously invalidating his own work. Then, Mendel was promoted at his monastery, lost basically all of the free time he'd previously used to investigate genetics, and then he died young of nephritis. His work would be rediscovered after many decades by other budding naturalists, but not all stories have happy endings. The following year, Prussian biologist Ernst Haeckel, Darwin's greatest supporter in Germany, would publish General Morphology of the Organism and his seminal concept, ontogeny recapitulates phylogeny. Put simply, Haeckel had studied countless embryos at various stages of development and argued that the development mimicked evolutionary history, explaining why human embryos have gill slits and tails before reorganizing those features later on. Now, some of Haeckel's ideas have stood the test of time, and others, well...
Hold on, I got a Ku Klux Klan member on my page. Let me block this Ku Klux Klan member.
Haeckel was kind of like if you took Huxley and Agassiz and mashed them together. So instead of being a bulldog for evolution, he was like a bulldog for race science, or like a bulldog for eugenics. Haeckel actually met Darwin in 1866 and referred to him as some kind of exalted sage, but Darwin actually found Haeckel's political and social perspectives to be offensive. Incidentally, Darwin felt the same way about the so-called social Darwinism, which was being advocated for by some of his contemporaries, like Herbert Spencer or Francis Galton.
As much as I'm gassing them up here, I would be remiss if I didn't point out the evident racism and sexism in the works of Darwin and Huxley as well. As progressive as they were in some ways, they too were men of their time.
Spencer took Darwin's observations and applied them to human society. Stronger societies would necessarily outcompete and eliminate weaker ones. Galton would take it a step further and argue that humans ought to take our evolution into our own hands and select for beneficial traits within our species, suppressing detrimental ones. He would coin the term eugenics in the year 1883. Thanks to Haeckel, Spencer, Galton, and others, social Darwinism, which was often completely divorced from evolutionary theory even as a concept, would gain popularity in the United States as well as elsewhere and allow people to justify inflicting enormous amounts of cruelty upon one another. For the time being, that honor belonged to Agassiz and others who used creationism to such ends. In 1867, Huxley finally laid eyes on Archaeopteryx, comparing it to Megalosaurus fossils housed within the same building. Not only were the hips, the ilium in particular, strikingly similar between Archaeopteryx and Megalosaurus, but both animals had avian hips. Right around this time, Johannes Wagner would pull Compsognathus from the German quarries, a chicken-sized dinosaur with light bones and the same avian hips. This tiny creature was also more primitive than even Archaeopteryx in numerous skeletal features. It was, in essence, the link between the dinosaurs and primitive birds. Those American publications on dinosaurs with small forelimbs, such as Hadrosaurus, emerged from the rubble of the Civil War and lent more support to the idea that these dinosaurs may have been bipedal as Mantell had proposed, rather than Owen's lumbering quadrupeds. 1 year later, this mighty dinosaur would be mounted in the Academy of Natural Sciences in Philadelphia. It was the only one on display like this in the entire world, and promptly triggered dinomania in the United States. That same year, the 8th Duke of Argyll would advocate for divinely guided evolution. The tide continued to turn. Huxley outlined his argument for the dinosaurian affinity of modern birds officially in a talk that he gave in 1868, a groundbreaking speech that impressed all in the audience, including Richard Owen. Michael Taylor notes that this would have been a particularly damning talk for Owen's orthodox sensibilities. The morphology of all of the fossils thus far were proof that the facts of paleontology were not opposed to the doctrine of evolution, but, on the contrary, enabled us to form a conception of the manner in which birds may have evolved from reptiles. The fowl that may fly above the earth, supposedly created by the Lord on the 5th day of the first week, had in fact evolved from the 6th day's creatures that creepeth upon the earth. This same year, Haeckel published the first evolutionary tree, including real taxa, with spaces for proposed missing links, which he thought would be found eventually. They were. One of these links he called Pithecanthropus elaeus, the speechless ape man, and he proposed it would have been upright and bipedal, but without the ability to talk. Art of this hypothetical hominin would be created by Gabriel von Max, to the delight of Haeckel. Back in the United States, a disgruntled New Yorker set to a noble task: embarrassing creationists. The story goes that George Hull had gotten into an argument with the congregation at a local Methodist revival. The Methodists insisted that Genesis 6:4 meant real giants had once roamed the land, something Hull found ludicrous. Hull, however, was at a Methodist meeting, so he was promptly outnumbered, his skepticism soundly shot down. As such, Hull did what any dedicated and vindictive person would do: he resolved to humiliate them. Hull wanted to put a spotlight on the gullibility of creationists, so he tricked tricked local quarrymen into mining a block of gypsum and then sent it to a pair of German stonecutters in the city, having them sculpt a giant man in his own image. Hull treated his giant facsimile with acids, stains, and small tools to make it look old. Then he shipped it to his cousin's farm and had it buried on his property. Under the guise of digging a well, it was discovered and put on display as a giant petrified human, the Methodist Revival's Nephilim. Truly a hater to rival Cuvier. The giant was shortly after examined by Othaniel Marsh, famous paleontologist, who immediately saw it for what it was, as a forgery. A most dedicated humbug, but local theologians and preachers defended it as an authentic proof of the Nephilim. The whole affair was obviously quite cruel on Hull's part, but they kind of made his point for him, didn't they? Allegedly, P.T. Barnum tried to buy this sculpture at one point, but today, the Cardiff Giant can be found in, I kid you not,
Marvin's Marvelous Mechanical Museum in Michigan.
This would not be the first or last archaeological or paleontological hoax, but luckily, frauds are often sussed out when enough eyes pry. So Darwin had been in ill health for decades now. He was in his 50s, and he'd noticed that Huxley and Lyell had seen quite a bit of success in their human-centered works. Darwin had talked a bit about human evolution up to this point. He'd mused about it quite a bit in private, but speaking publicly was something he was always reticent to do. It was time to break that seal. Darwin had scarcely mentioned the implications evolution by natural selection had on humans in origin and in his succeeding works. Subsequent editions of the book had tackled new arguments and included new fossils, but refrained from systematically outlining what naturalists like Huxley had been bullishly defending publicly since the very first edition, that humans were animals, apes, which evolved from other, more primitive forms in an unbroken chain to the last common ancestor shared by all life. This notion needed a defense all its own. It was one thing to suggest evolution in general, another entirely to suggest man in all his mental prowess had come from, and still was, a beast. Huxley had done a good job setting the stage, and Darwin would incorporate his and Lyell's work into his most audacious book yet, The Descent of Man. The Descent of Man was an argument for several controversial ideas. One, that humans were apes which shared a common ancestor with all other life on Earth. Two, that all man's higher faculties existed in other animals either precisely or in more basic forms. And three, that all living humans were of the same species and had descended from an ancient ape ancestor which probably lived in Africa. That last point was specifically in support of monogenism, the idea that all human races are related and unified in stark contrast to polygenism, the idea that each race was either specifically created, a la Agassiz, or specifically evolved from different ancestors, a la Haeckel. Darwin also outlined another new and groundbreaking concept in that text, sexual selection, which explained seemingly detrimental male characteristics as a result of female preference for those characteristics. The Descent of Man was overwhelmingly well received by the scientific community because it was essentially just origin, evolutionary theory, base level, but applied to humans. Detractors had to come at this from a very different angle, and namely that was what it had been, pointing madly at Genesis. Being decidedly unscientific as it was, that idea and that particular counter-argument had been put to bed with the geologists of the Enlightenment. It had no power here. A lot of other arguments sort of came from the culture.
This man-to-monkey hypothesis threatened to remove humans from their exceptional place in nature, and thus from their defined responsibilities and eventual reward. Was man not created by God to be the only emotionally complex and moral creature? Darwin thought not, and he wrote an additional book for that case as well. In The Expression of Emotion in Man and Animals the following year, he outlined what ethologists would formalize a century later. Animals display the full range of emotions found in humans, and may even understand a more basic form of morality. All the uniqueness of man, Darwin argued, was of degree, not kind. Resistance to evolution was crumbling, and indeed, species fixity had seemingly gone the way of diluvialism. The question now wasn't, did change occur, but how much change occurred? When did it occur? Where did humans fit in all of this?
Dissent had been well received. That was due in part to the road paving done by Lyell and Huxley. But even those who found Dissent to be an excellently argued text had their reasons for reticence on the full acceptance of Darwin's idea. The first had to do with natural selection. Could this blind process actually lead to the species diversity observed today and all of the marvelous mechanisms and specializations we see within any given organism? Or were there perhaps other mechanisms at play? Or maybe God was actively guiding it, and that could be something in the future we may be able to scientifically investigate. And the second reason for dissent was the actual breadth of evolution by natural selection. Did this unite all organisms into a last universal common ancestor, or was it limited in its scope? Had God perhaps created these archetypal groups that then evolved a lot within themselves, but it wasn't like everything could be lumped into a single tree? And lastly, again, where did humans fit in? Could evolution by natural selection explain the pinnacle of life on Earth? Us? Richard Owen thought not. He had been dubbed Old Bones at this point by Vanity Fair and was still stalwart in a lot of his positions, but especially human exceptionalism, as he always had been. Owen would never really recover from his losses against Huxley, and his feuds over the years had caught up to him.
In 1866, Owen finally conceded the Great Hippocampus debate. In a footnote in On the Anatomy of Vertebrates, Owen at last admitted that all the homologous parts of the human cerebral organ existed in apes.
Richard Owen's scientific standing was in shambles by the year 1870. He would officially retire from work at the age of 79, but would live, presumably powered by venom and spite, until the ripe old age of 88. His last and arguably best contribution was the dedicated campaigning for and organization of the Natural History Museum of London, where all collected specimens still reside. Louis Agassiz would continue to rail against virtually all of Darwin's ideas, with a special distaste for common descent and monogenism, until he died in 1872, 1 year after Descent and a trip to the Galapagos. After his visit, he remarked,
"Darwin's hypothesis of gradual variation of species and the natural selection for preservation of those whose variations were favorable to them in the struggle for life seems to me to have few facts to sustain it and very many to oppose it."
He was the last great American biologist to propose special creation of species. Darwin's foes, and the foes of evolutionary theory, were dropping like flies. Young men tried to take up the mantle. George Mivart was a naturalist student of Huxley's, who, while accepting species change and some evolution, felt Darwin and his colleagues had taken it too far. Evolution needed a guiding hand and more mechanisms. He sniped enough at Origin that Darwin's 6th edition had a point-by-point refutation of Mivart's public criticisms. Dissent was a bridge too far as well. In one review, Mivart savaged the concept of human evolution by, according to Darwin, strawmanning, misrepresenting, and even altering entire sentences from The Descent of Man. Mivart had a thing against Darwin. He even went after his son. Darwin's kid had written a piece for the Contemporary Review that argued that divorce should be easier for women to get because of rampant abuse, and this caused Mivart to crash out on Maine. Allegedly, Mivart referred to the notion as hideous sexual criminality and unrestrained licentiousness. Darwin would cease correspondence after that.
Do you have anything you want to say to women?
I'm sorry, women.
Lord Kelvin maintained that there was not enough time for evolution by mere natural selection to explain modern biodiversity, arguing in 1871 that thermodynamics suggested a mere 100 million years for the age of the geologic column. No, Kelvin thought that God must have sparked life, populating Earth with this germ using a meteorite, and then providentially guided evolution himself.
these guys and their meteorites. The theologians and philosophers, the non-scientific academics ranged wildly in their thoughts on evolution. There were the purely atheistic acceptors, there were the acceptors who were Asa Gray-style theistic evolutionists, there were the Lord Kelvin-style theistic evolutionists who thought of more of a tinkering, active God in the evolutionary process. There were old Earth varieties still bopping around, and at this point there were even still a handful of old-school diluvialists, or young Earth creationists. One of the most famous last-leg diluvialists of this time would be Princeton's Charles Hodge, who argued that evolution was just a hypothesis in his 3-volume Systematic Theology published in 1872. Hodge despised Darwinism, which he thought of as inherently atheistic, an idea he outlined in What is Darwinism, published in 1874. But Hodge took it a step further. He argued that Darwinism specifically threatened religion. He was challenged by James McCosh, a Scottish philosopher, also haunting the halls of Princeton. McCosh, like Asa Gray, found harmony in evolution and scripture and felt that a definitive support for the former was coming. People needed to know sooner rather than later that these ideas could be copacetic. Both perspectives would be offered at Princeton for now. This conflict played out outside the church as well. John Draper argued that religion and science were evidently natural enemies, always duking it out through time, while John Fiske proposed that that simply wasn't the case. They could be married quite happily to one another, depending on how egalitarian their relationship. Darwin weighed in and, of course, supported John Fiske. Also, in the year 1872, came a surprising take on Neanderthal 1, some of the first Neanderthal fossils, if you will recall. Rudolf Virchow, a German anatomist and pretty strident skeptic of evolution, particularly human evolution, came out and proposed Mayer's rickety Cossack idea. That was actually right. And he'd also had rickets as a kid, and also a head injury as an adult, and also arthritis in old age. What of Gibraltar 1, the Neanderthal cranium and its implications? Virchow didn't seem to speak on it, and because he was a prolific scientist, the rickety Cossack narrative remained, again, for now. In the year 1875, Charles Lyell, father of geology, crusader for free science, devoted Christian, and dear friend to Charles Darwin, would die. He never came around to fully accepting Darwin's ideas. Human evolution was just a step too far for him. But Darwin didn't care. He was a friend first and a colleague second. Considering his age, former views, and position in society, I think his action has been heroic. Lyell had gone so far in harmonizing his theology and his science, and allowing that to be an option for everyone in the Western world. He just couldn't go the full distance. Asa Gray would, and then some. Darwin greatly respected his colleague, despite their differences. In a letter to a friend, he remarked, "No other person understands my views and has defended them so well as Asa Gray. If I ever doubt what I mean myself, I think I shall ask him." In 1876, Asa Gray published his own seminal work, Darwiniana. The full title was Darwiniana, Essays and Reviews Pertaining to Darwinism. This book was a collection of essays that Gray had written which reconciled evolution by natural selection and religion. It was a marvelous response to Hodge's What is Darwinism? God had designed evolution, just as he had all other natural processes of the world, to keep species proliferating in the face of change. I remain one who is scientifically and in his own fashion a Darwinian, and philosophically a convinced theist. The intricacy of organisms, their obvious design, was the result of a divinely inspired process, not an active tinkerer. Gray laid out his argument for science and scripture alike. Agreeing that plants and animals were produced by omnipotent fiat does not exclude the idea of natural order and what we call secondary causes. The record of that fiat, let the earth bring forth grass and herb yielding seed, etc., let the earth bring forth living creatures after his kind, seems even to imply them. Darwiniana was a hit in the United States and can be considered to be a major force in the acceptance of evolution by the public by way of showing that evolutionary theory need not be in conflict with anyone's given religion. There can be science-affirming Christians. In this way, Asa Gray may well be considered the father of theistic evolution. Darwin, for his part, would profess all his life that religion and his theory need not be in conflict. It seems to me absurd to doubt that a man may be an ardent theist and an evolutionist. You are right about Kingsley. Asa Gray, the eminent botanist, is another case in point. And Asa Gray was not alone in this. He actually had an unlikely ally in Louis Agassiz's student. He had a student. Louis Agassiz was dead. Joseph LeConte, a professor of geology at the University of California, wrote Religion and Science in 1874, as well as a follow-up on the history of evolutionary thinking in 1888. In these volumes, he outlined support for evolutionary theory and reconciled it with his faith by discussing his initial skepticism under Agassiz before his eventual enthusiastic endorsement. The real question is, was LeConte an advocate for race science like his predecessor and mentor, Louis Agassiz? And the answer to that is, kind of. He was against slavery, but he was also against suffrage, so better than Agassiz, but he was no Asa Gray. As is probably obvious, acceptance of evolution and even common descent was the norm in the scientific community at this point. People like Owen were a dying breed, and even modern dissenters like Mivart saw the devil in the details, not the concept writ large. Othaniel Marsh stated in 1877, "To doubt evolution is to doubt science, and science is only another name for truth." Interestingly, one of Darwin's regrets was calling the mechanism natural selection, which he felt implied agency to nature rather than something like natural preservation. That same year, John Murray III, the publisher of both Lyell and Darwin's most influential and important books, would write and anonymously publish Skepticism in Geology, a plea to return to catastrophism and flood geology. One must imagine that his zeal for progress, inquiry, and conversation just outweighed his own personal opinion, an attitude I think we could all stand to embody a little bit more. In 1878, Adam Winchell, a theistic evolutionist, penned Adamites and Pre-Adamites. This book argued that humans had descended from pre-humans that lived before Adam. In a world of Joseph LeConte's and Asa Gray's, unfortunately, Winchell was a LeConte. He proposed that non-white people exemplified a pre-Adamite form of human, because, obviously, Adam himself was white.
Yep, that tracks.
Winchell was great at making geology exciting for people, but he would be fired from Vanderbilt for holding some questionable views on Genesis. Fired for racism? No, fired for evolution believing. By and large, this seemed to be a pretty uncommon incident. However, evolution cancel culture, and this is because, as I've been saying, most of the scientific community was on board with evolutionary theory and with common descent. It seemed as though, for special creation, time was up. With the scientific consensus more or less established for both biodiversity and the age of the Earth, these ideas began to meld together and blend out into the public with a little help from a new wave of dinomania. Long-necked dinosaurs like Cetiosaurus emerged from the ground in the UK, and out in the American West, Cope and Marsh couldn't find new dinosaurs fast enough, and now mammals too were a part of the bone rush. Both of these paleontologists had met while in Europe in the 1860s, and at that time they were evidently fast friends and nearly, dare I say it, besties. They would name reptiles after each other. But those who know the story of the Bone Wars know that this would not last. While in Europe, Marsh would become friends with Huxley and meet Darwin, a pilgrimage which may have represented one of the biggest differences between Marsh and Cope. Cope was a dedicated Quaker, more like Mivart than Gray. He accepted that species could change. Indeed, he had written about the dinosaurian affinity of birds, but he applied the hand of God as a driving agent in addition to naturalistic processes. Marsh, on the other hand, was a Darwinist through and through. Huxley would visit in 1876 and would lecture to a packed audience alongside Marsh and the latter's fossil collection, dazzling audiences with demonstrations of their connection to birds. The Bone Wars of of the 1870s revealed towering sauropods, sinister theropods, and even more transitional birds linking the primordial monsters to modern avians. Ancient horses galloped from the Badlands, older four-toed to younger three-toed to modern horses, giving another transitional lineage for Huxley to lecture on. He compared the ancient and modern carnivorans, crocodilians, and fish, coming away finally in 1879 to declare, "Of paleontology, the evidence of many existing forms of animal life from precursors is no longer a hypothesis that is open to discussion." One can only imagine Huxley's reaction when, in 1881, a fossil formerly discovered in 1875 was sold to the Berlin Museum, a new Archaeopteryx fossil, this time with a complete head filled with teeth. How wonderful it must have been for Darwin, who had so lamented the incomplete nature of the fossil record early in his career, to see the burgeoning field of paleontology introduce so many transitional species to the world. "What progress," he remarked to Wallace, "paleontology has made during the last 20 years. If it advances at the same rate in the future, our views on the migrations and birthplace of various groups of animals will, I fear, be greatly altered." Of course he was right. Huxley's linear progressions that he spoke on all those years ago are now magnificent bushes populated with thousands of species across space and time. But for Darwin to get to see his idea come to fruition and eventually acceptance, his early worries sated by the progress of science, wow. The next year, in 1882, Charles Darwin was in heart failure. At 73, he lay in his home in Down House, surrounded by loved ones, visited by close friends and colleagues from across the years. The shelves on his wall housed his life's work, including the original copy of Origin, the pages of which were scrawled with drawings made by his dear children. As he lay, attended by his wife Emma, he uttered his last words, "I am not the least afraid of death. Remember what a good wife you have been to me. Tell all my children to remember how good they have been to me." He died on April 19th. Darwin was originally to be buried close by, but the scientific community wouldn't have it. His colleagues, led by the president of the Royal Society, William Spottiswoode, organized to have him buried in Westminster Abbey, in what is now known as Scientists' Corner. Thomas Huxley, Joseph Hooker, and Alfred Russel Wallace bore their friend's casket to its final resting place, right next to the astronomer John Herschel. Darwin's funeral was attended by thousands of people: friends, family, scientific colleagues, enemies, philosophers, diplomats, politicians, the wealthy and the poor. And remember, this is in the mid-1800s. Darwin's influence simply cannot be overstated. Darwin's friends mourned. His old friend Asa Gray was overseas and could not attend, but he wrote to his family that Darwin's death was like the annihilation of a good bit of what is left in my own life. Darwin would be eulogized that day in Nature as an intellect which had no superior and a character which was even nobler than his intellect. When Darwin died in 1882, evolutionary theory and common descent were dominant in the scientific community on both sides of the Atlantic. A young Earth had been dead for decades, with species fixity falling more recently in time. Even those remaining dissenters like Owen, Mivart, and Cope, along with lesser-known names, held to a type of evolution and common descent. Further, through the tireless work of Asa Gray and other theistic evolutionists like him, the general public found a way to comfortably reconcile science and religion. All facets of being are subject to an endless stream of change. The trick is to adapt. From organisms to ideas, we learn and grow and evolve. Yes, there is grandeur in this view of life. During the 13th century, the Western world had a lot of questions about angels. These mysterious and very real entities were found all across the holy text, and they ranged from familiar to incomprehensible. Did they have physical bodies? Were they limited by time? Did they have the emotions and will of men? These were the real questions about the nature of divine beings in time and space, asked and investigated in earnest using Aristotelian principles. This was some of the first science at the dawn of the modern Western world, even if it seems odd to us now. Enlightenment scholars would ridicule these religious men caricature their work as trying to suss out how many angels could dance on the head of a pin, a notion that was as silly as it was impossible. The Enlightenment thinkers didn't suppose angels didn't exist. They accepted that these entities were beyond the scope of science, a field which aimed to study the natural world. This criticism came all while some of these new naturalists attempted to discover how the flood of Noah had formed the geologic column. Enlightenment thinkers, too, would be usurped by the next generation of devoted Christian scientists who further disentangled the study of creation from a literal reading of the Bible. Angels may not be corporeal, but dragons surely were, and their fossils spanned the vast annals of an ancient earth. The next wave of naturalists, many just as religious as their forebears, investigated change across deep history, as well as man's place within, revealing that God's world was not static but ever evolving, a most grand view of creation. Vast chalk and limestone cliffs required immense amounts of time to form. The accumulation of their sediment made from the bodies of trillions of microscopic organisms across millions of years. Great mountain ranges grew slowly, the marine life on their peaks having been buried in gentle conditions when their ranges dwelled beneath the waves. Rivers cut canyons as they meandered slowly, carving deeper and deeper every year, while coral atolls stretched upward as their seas swallowed their foundations. All of these features continued to reshape at a glacial pace in the present, as observed by geologists, and none of them bore the scars of a catastrophic flood in the past. Pouring from the earth were dragon's bones, denizens of a dead primordial eon before mankind when the world was more ferocious. More recently, fabulous mammals, only just extinct, stumbled from sulfuric swamps and arctic wastes. These animals were similar, but diverged from their modern counterparts. They had evolved through time in a grand transmutation thanks to the pressure of their environment, an idea supported by the same processes directly observed by modern science. All of this was obvious. It was chaos triggered by the happenstance origin of all things, or it was immaculate and calculated design by an ultimate creator, but it was obvious. The ancient age of the earth and the evolution of species by natural selection had triumphed over the diluvialists and the proponents of special creation thanks to scientists, religious and irreligious alike. Creationism in nearly every form was dead, and science and religion had killed it. The debate, at long last, was settled. Except, no, it wasn't. Not even close. The creationism, the diluvialism of the 1800s was just the opening salvo of a much longer, much nastier campaign against evolutionary theory and conventional science as a whole that would begin at the start of the next century and last until, well, it's still happening, isn't it? Now, I know what you're thinking. How is this possible? Creationism had been the dominant idea for decades. It had been the default idea, but it had been toppled by the empirical work of dozens of naturalists across the decades, like piecewise. And all throughout, naturalists from Buckland to Lyell had changed their minds as new data came to light, be it their own or the data put forward by their colleagues. They had been convinced by good empirical science. Like the position of the Earth, the age of the Earth, and evolutionary theory had been harmonized with theology of the day by the grueling work put forward by naturalists of all stripes. So how then? How could creationism return? Well, my dear viewer, it never left. In the year 1844, when Lyell's concept of an ancient Earth was gaining ground, and when Charles Darwin was contemplating his grandest idea, a young American girl was coming of age in a doomsday cult. Ellen G. White was only 12 when the leader of her cult, the Millerites, predicted that Jesus Christ would return that October on the 22nd. William Miller had deduced that date by studying prophecies in the Bible, a sort of numerology strategy that he pitched to the public in the year 1831. He was wrong, obviously, but his following was large enough that when the 22nd came and went like an ordinary day, the letdown became known as the Great Disappointment. It was so disappointing that young Ellen White began to have visions from God, one of which involved witnessing the literal creation of the world in 6 straightforward days and a global flood that created the fossils of the geologic column. Decades later, she would co-found the Seventh-day Adventist Church, a basic tenet of which is young Earth creationism, or a sort of new diluvialism.
In 1853, when tensions in the United States raged, the First Baptist Church of Minnesota was founded. This church would become a hotspot for the fundamentalist revival that would arrive with the 20th century. In 1866, in the wake of the Civil War, the KKK would emerge, keen on racial separation arguments that creationism allowed and evolution denied. In the 1870s, evangelist Dwight D. Moody would rage against evolutionary concepts, a foundation he would bring to the Moody Bible Institute, one of the first Bible colleges which would birth thousands of conservative preachers hostile towards evolutionary theory. In 1892, George McCready Price, a Seventh-day Adventist, would begin his formal attack on evolution and the ancient age of the Earth. Each of these events occurred more or less in isolation as compared to other such events, and their impact on science was none. That makes sense. There wasn't a scientist among them. But the ideas that these events and places and people nurtured would fester and grow until they became too much to hold behind the walls of a church or community center. They would spill out into the public at the dawn of the 20th century, crowed by grifters and charlatans, amateurs and fools. Some were well-meaning, but all were incorrect, which is why they didn't bring some new synthesis of ideas or a well-oiled theory to the table. Instead, they hiked out to the graveyard, shovel in hand, and wrenched from the tender earth the corpse of old ideas. In the halls of Bible colleges or growing churches, the fundamentalists hacked apart the mummified remains of the diluvialist hypotheses, stitched them back together with twine, and brought them screaming back to life with passionate sermons about the authority of Scripture and the arrogance of science. These shambling new creation models, weeping and weak amalgamations of ideas that science had already tried and sentenced, would be paraded about in the 1900s. They were found in the hordes of books and records and cassettes and tapes to the tune of millions, if not billions of dollars over the century. This was the age of zombie science, of undead creationism. How could these ideas take hold and proliferate so as to be vital in the creation-evolution battles of the 20th century when they were so frail as to be broken by the fledgling science of the 1800s? The answer is actually kind of obvious, although it took me a long time to see it. Creation science was killed by the 19th century, but the creation-evolution debates of the 20th aren't really about science. Not really. After all, the science was settled. In Mary Shelley's Frankenstein, Victor Frankenstein is not the monster, he's the monster's creator. But he's also the monster of the story himself. He's not the obvious threat in the form of a reanimated corpse, but he's the true threat in the sense that he has devised and carried out that creature's creation. Victor Frankenstein is the monstrous folly and arrogance of man. The monster is the vehicle Shelley uses to explore human nature, purpose, and fate. So here's the analogy. If the monster is the undead creationism of the 20th century, then Victor Frankenstein is the religious rights culture war for the soul of America. And that is what we'll be digging into in the next one. If you like what I do, if you enjoyed this documentary, please consider supporting me in the free way. That's liking, commenting, and subscribing. And if you want to support me in a more financial way, you can join my Patreon. Patrons get early access to videos when I'm on top of things, and they also get their names at the end of each and every video. So here at the end, I'd like to thank you from the bottom of my gentle and of course very modern heart for being such a curious primate, and I'll see you real soon next time.